Summary then. After the net.
After that,
Sorry, good morning.
good morning. Good morning. For 1 minute, நான் ரூமுக்கு வரேன் சொல்லுங்க.
சரி சரி.
A warm greetings to one and all present here. A warm greetings to one and all present here. The opening ceremony will be commencing shortly. The participants who will move during the program. The opening ceremony will commence shortly.
Hello. Hello.
Sir,
Echo ஆகுதா என்னது? Hello. ஏன் எக்கோ ஆகுதான்னு செக் பண்ணி சொல்லுங்க.
இல்ல.
Hello.
Sir, okay, echo ஆகல.
சார் என்னோட வாய்ஸ் எக்கோ ஆகுதுங்களா சார்?
என்னோட எக்கோ ஆகுதான்னு செக் பண்ணி பாருங்க. என்னோட எக்கோ ஆகுதா பாருங்க.
Sir, your voice is clear, sir.
Okay, thank you.
Hi, welcome to my channel.
I kindly request the participants to mute your mic.
All our dreams can come true if we have the courage to pursue them. On behalf of Department of Physics, Bharidasan University, I extend my warm greetings to everyone present here for the virtual celebration of Apeiron 2023. Watching your dream coming true is the moment to be cherished. The 6th state level inter-institutional physics meet, Apeiron 2023, is indeed a great moment that holds our boundless dreams that are to be cherished as its colors unfurl successfully. To begin with, I request Ms. Kritika Krishnan of 2nd MSc to give the welcome address.
A very warm greetings to everyone who have joined for inaugurating the 6th state level inter-institutional physics meet Apeiron 2023. It's my great privilege to welcome Professor M. Lakshmanan, Professor of Eminence and DST Serb National Science Chair. I heartily welcome Professor S. Rajashekhar, Professor, Department of Physics. I extend a warm welcome to Professor M. Sendilvelan, Head, Department of Nonlinear Dynamics. I am also happy to welcome Professor K. Jagannathan, Director of Center for Nanoscience and Nanotechnology. I welcome the graceful presence of Professor P. Muruganandan, and I'm also happy to welcome Professor R. Ramesh Babu, Associate Professor, and Professor T.C. Sabarigirishan, Assistant Professor, Department of Physics. I welcome Professor L.C. Nehru, Assistant Professor, Department of Physics. I extend my cordial greetings to our guest lecturers, Dr. Kanchana, Dr. T. Sriraman, Dr. Daniel. A heartily welcome and warm welcome to all our participants, Physics Forum members, research scholars, and postgraduates of our department. And finally, I welcome all the participants for making this celebration a wonderful and memorable one. Thank you.
Now, I'm glad to invite our Honorable Professor M. Sendilvelan, Head, Department of Nonlinear Dynamics, Bharathasan University, to inaugurate the celebrations by launching the inaugural video of Apeiron 2023, followed by an inaugural address.
Good morning to everyone. Respected teachers, dear colleagues, and my dear students. First of all, I would like to thank the Physics Forum of School of Physics, in particular Dr. Sabari Greesan, for inviting me to deliver the inaugural address for this wonderful occasion. It is really an honor for me to take part in this inaugural function. It is sixth gathering, and as a senior man, I feel excited to see my students' efforts to make this event happen. I'm amazed to see the sense of pride, the sense of participation, and the energy that my students put in the organization of this event. Even from my school days, I used to think that extracurricular activities should be an indispensable part of every student's life, especially during their academic years. As it is said that a sound mind lies in a sound body. I want all my students to be good at both studies and extracurricular activities. Today, I'm inaugurating the 6th Apeiron, and I have seen the progress of this event for the past 7 years in front of my eyes. Year after year, the Physics Forum is making our university proud, and this fills me with enough zeal to give all of you the best of facilities so you can thrive up to your most significant limit. Through various programs, the Physics Forum helps the student their hidden talents and help them in shaping their talent to the best of their capacity. Since most of you are new entrants to this event, I would like to recall about this event in a brief manner. The first Apeiron was conducted in the year 2018, in particular on 7th February. Apeiron means boundless. It is an inter-institutional physics meet. In the first meet, around 584 participants from 26 colleges appeared as 47 teams in the first Apeiron. The second Apeiron was conducted on the same 2nd February 2019. And surprisingly, the second Apeiron recorded an increase in the number of participants to 814, who appeared as 105 teams from 44 colleges. The third Apeiron was conducted on 7th February 2020. It recorded a drastic increase in the number of participants to 1,010, who appeared as 110 teams from 35 different colleges. The fourth Apeiron was successfully conducted on 6th March 2021 in an online mode, despite the lockdown and other restrictions. Around 858 participants from 37 different colleges had appeared as 130 teams in the online mode. The fifth Apeiron had evolved into a new forum. It was conducted in a hybrid mode, both online and offline, for the first time on 24th and 25th of March last year. It recorded around 1,100 participants and 175 teams from 40 colleges. The sixth Apeiron will be held today and tomorrow in a hybrid mode. It has recorded a drastic increase in the number of participants from 50 plus different colleges and 175 teams and a large number of participants, 1,900, it almost reaching 2,000. And in this year, we are planning to conduct 8 online events and 7 offline events. And if you look into the winners of the last 6 years, every year a different college wins. For example, in the first Apeiron, American College won, and in the second Apeiron, Gandhigram University from Dindigul, they take over the prize. And in 2020, Srimat Andavan College from Trichy, they got the prize. And 2021, Gandhigram, again they got a second time. And 2022, last year, Tyagarajar College from Madurai, they received the prize. And as far as, since we are conducting this program for 2 days, one day online and another day offline. In the online, we have covered the following events: Postify, KVSify, Electric Fusion, Quiz, and Mimilasius, Telegenic Lecture, and Braindover, Oppo Show. These are the programs we conduct by online. And offline, tomorrow, we are planning to conduct Jungle Run, Smart Markers, Physics Intact, Water Look, Picky Snap, Paper Gomi, even Enthusiast. And these are all different programs we are planning to conduct. And the winner will receive a trip to Black Thunder, which is worth around 17,000. Having recorded about the happenings, now I sincerely hope that the Apeiron will continue to bring glory to our university. Now it is time to me to roll on what is today's events, in which students from various colleges will display their skills, both in a team and individually. I hope those sitting in front of the desktop or mobile will have a great time watching everyone's perform. Now, with this note, I would also like to take my seat and watch the rest of the events. Once again, much thanks to all of you for being such a super crowd and turning this event into a greater one. Best wishes to everyone. Thank you.
I request Professor M. Sendilvelan to inaugurate the celebrations by launching the inaugural video of Apeiron 2023. Thank you, sir. Gratitude is not only the greatest of virtues, but the parent of all others. I would like to invite Ms. Lihita Sara of 2nd MSc to propose the vote of thanks.
Gratitude can transform common days into thanksgivings, turn routine jobs into joy, and change ordinary opportunities into blessings. I take immense pleasure in proposing the vote of thanks. Firstly, I would like to thank Professor M. Lakshmanan, Professor of Eminence and DST ACRB National Science Chair. I extend my sincere thanks to Professor S. Rajashekhar, Professor, Department of Physics. A heartfelt thanks to Professor M. Sendilvelan, Head, Department of Nonlinear Dynamics, for his valuable presence. I thank Professor K. Jagannathan, Director, Center for Nanoscience and Nanotechnology. I graciously thank Professor P. Muruganandam, Head, Department of Physics, Bharathasan University. I also thank Dr. R. Ramesh Babu, Associate Professor, Department of Physics. I would like to thank Dr. T.C. Sabarigirisan, Assistant Professor, Department of Physics. I extend my thanks to our guest lecturers, Dr. T. Sriram, Dr. Kanchana, and Dr. Daniel. I also thank all the faculties, Physics Forum, research scholars, and entire Apeiron team. I feel fortunate to thank all the staffs and students from various institutions for your presence and participations. Thank you all once again.
சரிம்மா. இவங்க இப்போ வந்து என்ன அனௌன்ஸ்மெண்ட் மட்டும் கொடுத்துருங்க. ஒரு நிமிஷம்.
Sponsors list.
I kindly request the participants to pay attention towards the rules and regulations of your respective events before joining the events.
The participants are requested to pay attention to the participants guide displayed on the screen and are kindly requested to contact the help desk in case of any queries. Kindly note down the timings of the events and join the Google Meet links respectively. Here is the participants guide for the offline events. An important announcement for the participants appearing for the offline events. Owing to the overwhelming participations, the events are pre-ponded. So we request the participants to report the registration desk between 8:30 to 9:30. Following it, there will be a short inauguration from 10 to 10:30 a.m. and the events will commence sharply at 10:30 a.m. So the participants of Jungle Run and Smart Markers are asked to report sharply, and I also kindly request all the participants to report without fail. For the effective conduction of the events, we request the cooperation of participants and the latecomers will be marked to be absent. So do kindly report sharply before the commencement of the inauguration. For any queries, you can contact the helpline numbers displayed on the screen. Thank you.
I would like to thank our proud sponsors, Black Thunder, Ooty Main Road, Mettupalayam, Shah IAS Academy, Trichy, Su Narayanasamy Arakattalai, Thiruvarur, Atmos Milk, SSM Group of Companies, Dadikombu, Dindigul, Pothys, Trichy, and Infinity Design Your Destiny, TVS Tollgate, Trichy. Thank you.
Now I request the participants to join your respective events. I wish all the participants the best of luck. Thank you.
Okay, please wait for
Okay, ma'am.
lot number 7. Lot number 7 is there. Mohammed Fatima, lot number 7. Lot number 7. Lot number 8 is there.
Yes, ma'am.
Lot number 8. Ashwini,
Yes,
time
ma'am.
starts now.
Good morning to all. I am R. Ashwini, second BSc Physics in Apeiron College for Women. From today, I explain about physics in space. A black hole in a place in space where gravity pulls so much, even the light cannot get out of it. The gravity is so strong. It formed when a large star caved. The black hole pulls matter from a blue star. In beside a artist drawn the correct view Milky Way galaxy. A black hole formed. The scientists think the smallest black hole formed when the universe began, when the center very big star fall. Most of the scientists were awarded in Nobel Prize in Physics 2020. Einstein theory, the gravity predicted of possible black hole behaved inactively in 1967. Black hole coined 1970 conversing in black hole. NASA in telescope discovery.
Lot number 8, your time is up.
Thank
Thank
you.
you for your presentation. Lot number 9,
Yes, ma'am.
your time starts now.
குட் மார்னிங் டு ஆல். என்னோட போஸ்டர் உள்ள கான்செப்ட் என்னன்னு பார்த்தீங்கன்னா ரெட் ஜெயிண்ட். இந்த ரெட் ஜெயிண்ட் மூமெண்ட்டுங்கிறது பார்த்தீங்கன்னா நம்மளோட சன்ஸ் வந்து இப்போ வந்து ஹைட்ரஜனையும் ஃபியூஸ் பண்ணி ஹீலியம் ரெடி பண்ணிட்டு இருக்குது. இப்போ ஹீலியம்ஸ்லாம் காலியானதுக்கு வரும் பார்த்தீங்கன்னா கார்பன் அந்த ப்ரொடியூஸ் பண்ணும். அப்போ பார்த்தீங்கன்னா நம்ம சன்னோட சைஸ் வந்து ரொம்ப பிக் ஆயிரும். அதிகப்படியான எனர்ஜியும் வந்து ஹீட்டையும் ப்ரொடியூஸ் பண்ணும். அதனால சோலார் சிஸ்டமில் இருக்கிற எல்லா பிளானட்ஸுமே வந்து டெஸ்ட்ராய் ஆக சான்சஸ் இருக்குது. அப்போ நம்ம எர்த்துமே டெஸ்ட்ராய் ஆகும். ஸோ நம்ம லீவ் பண்ணுறதுக்கு வந்து நியர்பை ஒரு ஸ்டார் சிஸ்டத்துக்கு போகிறதுக்கான ஒரு தேவை ஏற்படும். நமக்கு நியர்பையாக இருக்கிறது என்னன்னு பார்த்தீங்கன்னா ஆல்ஃபா சென்ச்சுரி ஸ்டார் சிஸ்டம். அது வந்து 4.37 லைட் இயர்ஸ் தூரத்தில் இருக்குது. இப்போ நம்மள்ட்ட இருக்க டெக்னாலஜி வச்சு அவ்வளோ தூரம் போகிறங்கிறது வந்து அந்த டைமுக்குள்ளே போகிறதுங்கிறது ரொம்ப இம்பாசிபிளான ஒன்று. ஸோ அதுக்கு சொல்யூஷனாக என்னென்னா ஆன்டிமேட்டர்னு ஒன்று இருக்குது. ஆன்டிமேட்டர்னு பார்த்தீங்கன்னா நம்ம பிக் பேங் உருவாகும் போதே மேட்டர் ஆன்டிமேட்டர் ரெண்டுமே ப்ரொடியூஸ் ஆகிருக்குது. பட் ஆனால் அனிகிலேஷனால இந்த ஆன்டிமேட்டருங்கிறது வந்து டெஸ்ட் ஆகி எனர்ஜியாக மாறிடுச்சு. ஸோ வந்து இந்த ஆன்டிமேட்டரை வந்து நம்ம ஒரு ஸ்பேஸ் கிராஃப்டோட ஃபியூலாக பயன்படுத்தினோம்னா நம்மளால அந்த நியர்பை ஸ்டார் சிஸ்டத்துக்கு ரொம்ப சீக்கிரமாக போக முடியும். ஸோ பார்த்தீங்கன்னா இந்த ஆன்டிமேட்டர்லேயும் ஒரு 2 ட்ராபேக்ஸ் இருக்குது. என்னன்னா இதோட எக்கனாமிக்கலாக இது வந்து ரெடி பண்ணுறது வந்து ரொம்ப ஹை. நெக்ஸ்ட் வந்து
Thank you for your presentation.
ஓகே மேம்.
Lot number 10,
Yes, ma'am.
your time starts now, ma.
I'm Sridevi of Devanayamal College. Today I'm going to speak about a bad spiral galaxy. Bad spiral galaxy is composed of 2/3 of bars. Mostly galaxies are 3 types: elliptical, irregular, and spiral. Today my topic is about a bad spiral galaxy. Why I chosen this topic means because Milky Way galaxy is our galaxy is made up of a spiral shaped galaxy. 65% of the spiral galaxies are bar. In our Earth, the bad spiral galaxy distance is 2.5 million light years away, and it was discovered by a Hubble Space Telescope and captured that formation of this galaxy is first the protogalaxy is formed. Protogalaxy is nothing but a dark matter and a gas under its own gravity. By the rotation of the protogalaxy, the spiral is formed. By the high density waves, the protogalaxy is converted into a bad spiral galaxy. First, it is a majestic bright color so it has 2 arms, on tightly bound arms one side and loosely bound on arms on another side. It consists of interstellar spaces. Interstellar spaces means helium and hydrogen is present. Helium is a gas filled inside that helium and hydrogen is an interstellar gases filled inside that bars, and it mostly consists of stars and spaces along it. In bad spiral galaxy, it has a black hole in center.
Lot number 10, your time's up, ma'am.
Thank you, ma'am.
Thank you for your presentation. Next comes Abhinaya, lot number 11. Abhinaya. Abhinaya, are you there? Abhinaya, lot number 11.
Yes, ma'am.
Your time starts now.
Yes, ma'am. Pleasant morning to all. I am Abhinaya. Here, physics in spaceல ஒரு unsolved mystery தான் இங்க string theory அப்படின்றது. இந்த string theory எடுத்துக்கிட்டோம் அப்படின்னா இது வந்து ஒரு யூனிஃபிகேஷன் தியரி அப்படின்னு சொல்றாங்க. தியரி ஆஃப் எவ்ரிதிங். இந்த தியரி ஆஃப் எவ்ரிதிங்ல இது நாள் வரைக்கும் ஜாயினே பண்ண முடியாத ஒரு 2 விஷயத்த வந்துட்டு இங்க வந்துட்டு சால்வ் பண்றாங்க. அதுதான் கிராவிட்டி அண்ட் குவாண்டம் பிசிக்ஸ் அப்படிங்கிற இந்த 2 விஷயத்தையும் அவங்க வந்துட்டு சால்வ் பண்றாங்க. அதாவது கிராவிட்டி அப்படிங்கறத வந்துட்டு கிராவிட்டான் அப்படின்னு சொல்லி 1960s கேப்ரியலோ வெனிசியானோ அப்படிங்கிற ஒரு சயின்டிஸ்ட் பிசிசிஸ்ட் வந்துட்டு கிராவிட்டான் அப்படிங்கிற ஒரு பார்ட்டிகலை எடுத்துக்கிட்டு ஸ்ட்ரிங் தியரி மூலமா குவாண்டம் பிசிக்ஸ்குள்ள கொண்டு வராங்க. ஸ்ட்ரிங் தியரி அப்படின்னா என்னன்னா, ஒரு குவாக்ஸ் அப்படிங்கிறது நம்மளுக்கு தெரியும், ரொம்ப டைனி எலமென்ட்ரிக்கல் பார்ட்டிகல். அந்த டைனி எலமென்ட்ரிக்கல் பார்ட்டிகல்ல ஸ்ட்ரிங் அப்படிங்கிறது வந்துட்டு ஒரு நூல் போன்ற ஒரு அமைப்பு அப்படின்னு சொல்றாங்க. அந்த நூல் போன்ற அமைப்புனால அதோட வைப்ரேஷன்னால ஃப்ரீக்வன்சிஸ் ஏற்படுத்தக்கூடிய ஷேப்ஸ் வந்துட்டு எவ்வளவு சைஸ் இருக்கும் அப்படின்னா 10⁻⁻35 மீட்டர் சைஸ் இருக்கக்கூடிய ஒரு ஸ்ட்ரிங் தான் அந்த குவாக்ஸ்குள்ளார இருக்கு அப்படின்னு சொல்லி ஒரு இமேஜினரியான ஒரு திங்கை கொண்டு வந்ததுதான் இந்த ஸ்ட்ரிங் தியரி அப்படிங்கிறது. பட் ஆனா இந்த ஸ்ட்ரிங் தியரியை மேத்தமெட்டிக்கலா சால்வ் பண்ணிருக்காங்க.
Lot number 11, thank you for your presentation.
Thank you, ma'am.
Next comes lot number 12, Pushpa. Pushpa, are you there? Lot number 12, Pushpa, are you there? Pushpa, lot number 12, Starflyer, are you there? Lot number 13, Cheryl, are you there? Lot
Yes,
number
ma'am.
13,
Yes, ma'am.
Cheryl, are you there?
Yes, ma'am.
Your time starts now.
Okay, ma'am. Good morning to all. I am Cheryl from Devanayamal College of Women. To explain about physics in space, I have taken Kepler's law. It was discovered by a German mathematician and astronomer, Johannes Kepler. Kepler is best known for his theories which explain about the motion of planets. The first law is law of orbit, which states that each planet moves around the sun in an elliptical orbit with sun at one of the foci. The second law is law of area, which states that the radial vector sweeps equal areas in equal interval of time. The third law is law of period, which states that the square of the time period of revolution of a planet around the sun in its elliptical orbit is directly proportional to the cube of the semi-major axis. Today, Kepler's law is being used to design and launch satellites in space. From the second law, it is very clear that the planets travel faster when they are nearer to the sun and slower when they are away from it, to cover equal area in equal interval of time. From this, it is clear that Kepler's law is one of the greatest discovery in space research. Thank you, ma'am. Thank you for this opportunity.
Lot 13, your time's up. Thank you for your presentation. Lot number 14. Lot number 15. Lot number 15. Lot number 15, Nandakumar, are you there?
Ma'am, my name.
Lot number 15, Nandakumar is there? Nandakumar 15, are you there? Lot number 16?
Yes, ma'am.
Lot number 16, Harikara.
Yes, ma'am.
Your time starts now.
In this picture, there was an astronaut, Neil Aldrin Armstrong. He is an American astronaut and an aeronautical engineer. He was the first person to walk on the moon. Some of these scientists thought that the fact that we see the map is just a result of the coincidence, but it's not. Ordered under Professor of Planetary Science and California Institute of Technology, he and his colleagues have now found that is not in the case. Anderson, along with Peter Goldrich, the lead professor of astrophysics and planetary physics, embraced the dreams of Erbe University of German, described their finding in a paper published online on February 26 in the journal Letters. Through a disappointing process was first explained by the voltage in 1960s. Tidal force turned on the moon, creating another elongated shape that moved to stay on whichever side was closest to the Earth at the moment. In the in this way, as a result of Earth gravity, the moon becomes looked into the orientation with its long axis pointing towards our planet. The real coincidence is not that the man faces Earth and senses. Instead of the real coincidence is that the moon disappointing rate was just the right amount to create such a fascinating physics and load the
Lot
coin.
number
Fear about moon is called
Lot
seliphobia.
number 16.
Love the moon is called seliphile. Okay.
Lot number 16. Thank you for your
Yes,
presentation.
ma'am.
Thank you, ma'am.
Next, lot number 7.
Yes, ma'am.
Lot number 17.
Yes, ma'am.
Start your presentation. Your time starts now.
Thank you, ma'am. Have we ever wondered about the origin of universe? There are many theories which support the origin of universe, but let us talk about the widely accepted theory called the Big Bang theory. According to the Big Bang theory, the universe was once a small, dense, infinitely hot and a gravitational singularity. It is similar to the size of a proton. After a huge explosion, the universe started to expand, and thus the Earth and where we reside on the Milky Way galaxy is also created. It is often misconceived that the Big Bang theory explains the birth of a universe. It's totally wrong. It just explains the evolution of a universe. It relies on two basic principles, Einstein's relativity and cosmological principle. We believe that the universe is a static, but when Hubble was measuring a light from a distant galaxy, he noticed that there was a shift towards the red end of a spectrum. This is due to Doppler effect. This indicates that the galaxies are moving from each other at a greater speed. So this implies that the universe is still expanding. This provides a very good evidence for the Big Bang theory.
Lot number 17. Thank you for
Yes,
your
ma'am.
presentation.
Thank you, ma'am.
Next, Rajalakshmi. Lot number 18. Rajalakshmi, lot number 18. Rajalakshmi, lot number 18. Are you there?
Yes, ma'am.
Lot number 18. Your time starts now.
Somewhere, something incredible is waiting to be known with this quote. Somewhere, something incredible is waiting to be known with this quote. I start my presentation. Myself, Rajalakshmi from National College. The quote is based on Big Bang theory, which explained the way the universe began as the surface point, expanded and stretched to grow. The now in about 43 seconds, it begins with the catalysis at generate phase and as well as all matter and energy. The universe will ever hold. After 10,000 years, and radiated with different wavelengths of X-ray, radio waves, and UV rays. After 3,000 million years, birds of stars and galaxies occur. After 5 billion years, formation of sun occurs within a cloud of gas in a spiral arm of the Milky Way galaxy. Over 15 billion years, the formation of the spatial and keeps growing even after several evolutions still face in mystery over which people is trying to make history. This is how the universe now expanding till the second infinite and now. I'm concerned with phases full of physics.
Lot number
Yes, ma'am.
18.
Thank you, ma'am.
Thank you. Comes Pererivalan. Lot number 19. Lot number 19. Lot number 19, Pererivalan.
Yes, ma'am. Present, ma'am.
Your time starts now.
My name is Apeiron from JJ College of Arts and Science from Pudukkottai. I'm going to explain about physics. Space physics is the branch of physics that tries to answer some of the oldest questions humans ever had, such as that what is our place in this universe or where did we come from. These questions have been asked for thousands of years and are likely to continue being asked and answered for thousands more. Now let me explain. The scientific content of solar and space physics is broad, involving the sun, heliosphere, magnetosphere, ionosphere, upper atmosphere, and the complex interactions among them, solar terrestrial and solar planetary relations. Review of the current status of the subjects has resulted in a set of scientific objectives that can be summarized as follows. First one, solar physics. To better understand all the process linking the solar interior to the corona, we need to study the following. The sun's global circulation, how it reflects interior dynamics, is linked to luminosity modifications and is related to solar cycle. Second one, physics of the heliosphere. The sun has the only stellar exosphere where complex X phenomena common to all stars can be studied in situ observations of the sun and the heliosphere. The plasma envelope of the sun, extending from the corona to the interstellar medium, provide the basis for interpreting a variety of phenomena ranging from production of X-ray and gamma ray radiation to cyclical activity and long-term evolution.
Lot number 19, your
First,
time.
thank you, ma'am.
Next comes Kavitanjali, lot number 19. Lot
Yes,
number
ma'am.
20. Your lot number 20, Kavitanjali, your time
Yes,
starts
ma'am.
now.
A very good morning to everyone present here. I'm Kavitanjali from Lunar Rover team to present my poster themed physics in space. So here it is. Now we are going to see about an interesting James Webb Space Telescope. It is an infrared observatory orbiting the sun about 1 million miles from the Earth to find the first galaxies then formed in the early universe and to see stars forming planetary system. Using its infrared sensing instrument, the telescope can peer past dusty regions of space. Webb has the capacity to look 13.6 billion light years distance, which will be farthest we have ever seen into space. Next, we are going to see about supernova. Supernova is a powerful and luminous explosion of star. Supernova are triggered by two basic mechanisms: the sudden reignition of nuclear fusion in degenerated stars such as white dwarf, or the sudden gravitational collapse of a massive star's core. Supernova are major source of elements in interstellar medium from oxygen to rubidium. The last supernova to be directly observed in the Milky Way was Kepler's supernova in 1604. And last, we are going to see about black hole. Black hole is a region of space-time where gravity is so strong that nothing, including light or other electromagnetic waves, has enough energy to escape its event horizon. A central law of black hole predicts that the area of the event horizon. Thank you, ma'am.
Next comes lot number 21, Jasmine Beulah. Jasmine Beulah.
Yes, ma'am, I'm present here.
Lot number 21, your time starts now.
Hello everyone, this is Jasmine Beulah Salome from Lady Doak College. The poster in physics in space represents the fundamental part of space and has important implications in not only to understanding the universe, but also for practical theory, everyday life, including operations of communications and weather satellites. To understand the sun and its interactions with the earth and the solar system, including the space, weather, are termed as heliophysics. Apart from this, the explosions of stars, which is called supernova, and expansion of universe, that's about Hubble law. It's all about just exploring things above you. In 2022, scientists have detected a mysterious radio signal from a galaxy far, and gravitational waves are ripples in space-time caused by some of the most violent and energetic processes in the universe. Albert Einstein predicted the existence of gravitational waves in 1916 in his general theory of relativity. The most interesting thing is that only 5% of space is being explored. Remaining stay as unexplored and theories and discoveries. Explore space with a space. This is Shweta, and thank you.
Lot number 21, your time's up. Lot number 22, Shiva Prakash, are you there?
Yes, ma'am.
Lot number 22, Shiva Prakash.
Yes, ma'am, I'm here.
Your time start now.
Hi, I am Shiv Prakash. Today I am explaining about the three law of our Mother Earth. Earth obeying a three law. First is Coriolis effect. This the Earth rotates on its axis and circulating the air is deflection toward the right in the northern hemisphere and toward the left in the southern hemisphere. This deflection is called Coriolis effect. This is also known as Ferrel's law. This deflection is more when the wind velocity is high. Next, considerations of angular momentum is a physical property of spinning system such that spin is remain constant unless it acted upon by the external torque. Put another way, the speed of the rotation is constant as long as the net torque is zero. For example, the Earth acts like a gyroscope in its orbit and around the Sun in that it maintains the directions of its spin axis is the space. The implications of considerations of angular momentum is that angular momentum of the rotor maintain not only its magnitude but also its directions in the space is observed of the external torque. Thus, the axis and northern hemisphere.
Lot number 22.
Thank you, ma'am.
Lot number 22, your time's up.
Thank you, ma'am.
Okay. Lot number 23, Sundaramurthy.
Yes, ma'am.
Lot number 23, Sundaramurthy.
Yes, ma'am. Yes, ma'am. Sundaramurthy.
Your time start now.
திருவிக்கால படிக்கிறேன் மேம். நான் வந்து பிசிக்ஸ் இன் ஸ்பேஸை பத்தி பேச வந்தேன் மேம். விண்வெளி ஆராய்ச்சியாளர் வந்து விண்வெளி ஓட்டத்தின் மூலம் செவ்வாய் நோக்கி போறாங்க மேம். அங்க போயிட்டு செவ்வாய் நோக்கி செல்றாங்க மேம். சென்று அதனை பற்றி ஆராய்ச்சி செய்ய இருக்கிறாங்க மேம். அங்க வந்து அங்க அவர்கள் என்ன நடக்கும் என்று சிந்தனையுடன் இறங்கி இருக்காங்க மேம். அவங்க சிந்தனையோட போயிருக்காங்க மேம். ஒரு சிந்தனையோட இங்க இப்படிதான் இருக்கும், இப்படிதான் நடக்கும் அப்படின்னு ஒரு சிந்தனையோட போறாங்க மேம். இறங்கி அவர்கள் எதிர்பார்த்த நிகழ்வுகளுடன் உண்மையானதா என்று ஆராய்ச்சி பண்ணிட்டு இருக்காங்க மேம். அவங்க சிந்தனையோட எதிர்பார்த்தாங்க போய் அங்க என்ன நடக்கும், இதுதான் நடக்கும் அப்படின்னு அவங்க சிந்தனையோட போய் அவங்க வந்து அங்க ஆராய்ச்சி பண்ணிட்டு இருக்காங்க மேம். அங்க ஆராய்ச்சி பண்ணி இந்த மாதிரி உண்மையான நிகழ்வு நடக்கும் அப்படின்னு சொல்லி ஆராய்ச்சி பண்றாங்க மேம்.
Sundaramurthy, are you there?
Ma'am, thanks. சொல்லுங்க மேம்.
Your time is up.
Thank you, ma'am.
Lot number 24, S. Aravind. Lot number 24, S. Aravind, are you there? Yes, Aishwarya.
Yes, ma'am. Present, ma'am.
Your time starts now.
Yes, ma'am. Good morning, everyone. I'm coming from Ezra College. I take the topic the wave. Wave is a longitudinal unknown wave. Waves are characteristics. Energy. Energy is an amplitude. Amplitude refers to the distance, the maximum vertical displacement of the wave from its mean position. The longitudinal amplitude, the highest energy. Energy is an amplitude. The frequency of the wave is the number of times the present per second that the wave cycle. The frequency is measured by the Hudson circle per second. The period is a wave is the time between wave crest. The period of the measure is time units such as second. It takes a circuit crest to pass the specific points. One wave is in one wave contains six seconds. And the types, the mechanic waves are the
Lot number 25, Aishwarya. Your time's up.
Yes, ma'am.
Your time's up. Lot number 26, Remilin. Lot number 26, Remilin, are you there? Lot number 26, Remilin. Your time starts now.
Good morning, everyone. I'm Remelin from 3rd year BSc BH Physics from Gandhigram Rural Institute. First of all, thank you so much for giving me this opportunity. I'm here to present my topic on physics in space. We all know that in this 21st century, technology has developed a lot. We are living in Earth due to technological advancement in physics and science. We can able to travel in space. There is a possibility of living in other planet and there may be a new creature in space. Thus, in order to depict those things, I have drawn this image. Art is long, but life is short. Science has no end. There are a lot of research going on regarding space by ISRO, NASA, and all, like black holes, satellite, planet, galaxies, stars, etc. Soon our world on Earth is extended to the space due to technological advancement. Hence, it's all about technological advancement of physics in space. Once again, thank you for the opportunity. Thank you, ma'am.
Thank you for your presentation. Lot number 27, G. Archana. Lot
Good
number
morning to
27, G. Archana.
Good morning to all my
Your time
friends.
starts now.
Good morning. I am from GTN Arts and Science College, Dindikal. My topic is physics in space. APJ Abdul Kalam. In 19 In 1969, Kalam was transferred to the Indian Space Research Organization, where he was the project director of Indian first satellite launch vehicle, which successfully developed the Rohini satellite in near Earth orbit in July 1980. Kalam had first standard work on the expandable rocket project. Opened the door for Indian in the field of space technology. APJ Abdul Kalam was also called a rocket man. Thank you, friends.
Thank you, Archana. Lot number 28, Samyukta Shri.
Yes, ma'am.
Lot
I am
number
R.
28,
Present, ma'am.
your
Hello?
time starts now.
Yes, ma'am. I am R. Shamyukta from Periyar University. I present some of our major achievements in space. We proposed Big Bang theory to explain how our universe is evolved. The contribution of many scientists helps us to achieve more in space science. In that row, I mentioned few of them. The first one is Galileo. He is known as the father of modern science. He argued that Earth and other planets revolve around the Sun, and it is confirmed later by others. Einstein. The theory of relativity is proposed by him, which is revolution our understanding of space and time. The Vikram K. Sarabhai is known as the father of Indian space program. He initiated the space program in India. After that, we conquered many achievements in space science. Following that, Aryabhatta is our first satellite, and our major achievements is Chandrayaan-1. It discovered the presence of water molecules in lunar soil, and the Mangalyaan is the Mars mission. It is the India's first interplanetary mission. ISS, the International Space Station, is the largest structure humans have ever put into space. The black hole. The first image of a black hole is recently captured by scientists using the Event Horizon Telescope. It is at the center of our Milky Way galaxy. The
Lot
Hubble
number
Space
28,
Telescope.
your time's up.
Okay, ma'am. Thank you, ma'am.
Lot number 28, lot number 29, Ram Kumar. Lot number 29, Ram Kumar.
இதுல வரல தானே
Ma'am, lot number 14,
29,
Pushpa. Ma'am, lot number 14, Pushpa here, ma'am. Sorry, ma'am. Network problem.
We will call you later, ma'am.
Okay, ma'am.
Yes, Pushpa, we will call you later.
Ma'am,
Okay, ma'am.
ma'am, I'm from National College, ma'am. Ma'am, presentation very good, ma'am.
Rajlakshmi, we will call you later. Please unmute. Please
Ma'am,
mute your
ma'am,
mic.
I finished, ma'am. But presentation பண்றவங்களுக்குள்ள தெரிய மாட்டேங்குது, ma'am. Screen share ஆகல, ma'am.
Okay, இப்போ யாரு? Mute. Is the screen is visible? Participants?
Yes, ma'am.
Okay. Lot number 29, Ram Kumar. Are you there? Lot number 29. Lot number 29. Lot number 30.
Yes, ma'am. Muhammad Ali is here, ma'am.
Okay. Your time starts now.
So, good morning to all. Do you believe that we are viewing the past object in space? Yes, that's true. For example, if we see the stars on the sky, it is not same as we see this time because the stars might be destroyed and become a white dwarf or a black hole. As our sunlight takes the 8 minutes 20 seconds to reach our Earth's surface, in these 8 minutes 20 seconds into the past, similarly, the light takes larger distance to travel from the longer distance stars. See here in this poster, there is a two planets. Assume the planet 1 and planet 2 are separated by 1 light year distance. After the some millions light years, the star will destroy and become the white dwarf. The planet 2 can be observed the white dwarf earlier than the planet 1 as it is in nearby distance to the star. Planet 1 will while they destroy the starlight. The main reason behind this is light takes time to travel longer distance in space. So conclude of this presentation, light needs time to travel across the vast distance of space to reach us. Most of the stars that the telescope will reveal may actually be long dead today, but as their ancient light makes as the lengthy journey across the universe. This is the concept I tried to explain in this poster
Lot number
presentation.
30.
Thank you. Thank you.
Lot number 30, your time, sir. Thank you.
Thank you, ma'am.
Please don't share your screen in between our presentation. Lot number 31, Hehita. Lot number 31.
Good morning.
Lot number
I
31.
am from T2. Hegita present, ma'am.
Lot number.
Hello, ma'am.
Okay, your time starts now.
Isaac Newton formulated gravitational theory in 1665 or 1666. Newton discovered the relationship between the motion of the moon and the motion of the body falling freely on Earth. By his dynamic and gravitational theory, he explained Gibbs' law and established a modern quantity. Science of the gravitational, Newton assumed the extraction on the attractive force between the massive body. Newton consulated that a force exerted by the earth on the moon is needed to keep it in a circular motion about earth rather than moving in a straight line. He realized that his force would be at long range, the small as the force with which earth pulls object on this surface downward. When Newton discovered that the acceleration of the moon in 1/3600 smaller than the acceleration at the surface of the earth, he released the number 3600 to the square of the radius of the earth. He calculated that the circular orbital motion of the radius r and period t require a constant inverse acceleration equal to the product of 4 by square and the ratio of the radius to the square of the time. Earth in gravitational formula in Newton is equal to A is equal to 4 by square.
Lot number 31, your time's up. Lot number 31, your time's up. Lot number 32, M. Lalita.
How are you?
Lot number 32, M. Lalita, are you there?
Yes, ma'am. I'm here. I'm Lalita. Good morning.
Archana, please mute your mic. Archana. Lalita, your time starts now.
Good morning to all. I am Lalita from Palur College of Science and Management. First நான் எடுத்துருக்க டாபிக் physics in space. அதில் வந்து பிளானட்ஸ் பற்றி ஃபஸ்ட் பார்க்குறோம். பிளானட்ஸ் அப்படிங்கிறது பிளானட்ஸோட ரெண்டு இது என்ன அப்படி மெயின் கான்செப்ட் என்ன அப்படின்னா, ஃபர்ஸ்ட் பிளானட் எந்த பிளானட்டா இருந்தாலும் தன்னைத்தானே சுத்திக்கிட்டும் சூரியனை சுத்தி வருது அப்படின்னா அதுதான் வந்து பிளானட்ஸ் அப்படின்னு சொல்லுவாங்க. இதுல வந்து ரொம்ப ஸ்பெசிபிக்கா இருக்கிற பிளானட் அப்படிங்கிறது வந்து பாத்தீங்கன்னா 8 பிளானட் சொல்லுவாங்க. 8 பிளானட்ஸ்ல வந்து ப்ளூட்டோ வந்து யாரையுமே இது பண்ணாம தன்னைத்தானே சுத்திக்காம சூரியனே சுத்தி வராம அது ஒரு அரேஞ்ச்மெண்டாவே இல்லாததுனால அதை வந்து இது பண்ணிட்டாங்க. அதனால வந்து அது கிடையாது. அதனால 8 பிளானட்ஸ் மட்டும் இருக்கு. இதுல வந்து பூமியில தான் நம்ம இருக்கோம். அதுக்கப்புறம் வந்து செவ்வாயில நம்மளால இருக்க முடியுமா என்ன அப்படிங்கறத பாக்குறதுக்காக தான் மங்கள்யான் அப்படிங்கிற ஒரு இது ஸ்பேஸ் அனுப்பியிருக்காங்க. தென் ஆதித்யா அப்படிங்கிற ஒரு ஸ்பேஸ வந்து இந்தியா வந்து சன்ல வந்து என்னென்ன இருக்கு என்னென்ன இருக்கல அப்படிங்கறத வந்து இது பண்றதுக்காக அதை வந்து அனுப்புறதுக்காக வெயிட் பண்ணிட்டு இருக்காங்க நம்ம இந்தியா. அதுக்கப்புறமேட்டு இன்வென்டர் எடுத்திருந்தேன். இன்வென்டர்ல வந்து என்ன அப்படின்னா வந்து இது இப்படிதான் அப்படிங்கறது வந்து யார் வேணா சொல்லிடலாம். பட் இது வந்து எல்லாமே டெரிவே வந்து இது பண்றது வந்து இன்வென்டர்ஸ் தான். அக்யூரேட்டா ப்ரூஃப் கூட சொல்றதுனால
Lot number 32, your time, sir.
Thank you, ma'am.
Lot number 33, Murshida Shirin. Lot number 33, Murshida Shirin, are you there?
Yes, ma'am.
Your time starts now.
Happy morning to all. Today I am explaining about the space and astronaut.
Murshida Shirin. Murshida Shirin.
Yes, ma'am.
Please don't share your screen.
Today I am explaining about
Murshida
the
Shirin.
space. Yes, ma'am.
Murshida Shirin, please don't share your screen. You can start your presentation.
Okay, ma'am. Happy morning to all. Today
Your time starts now.
Space under astronaut. Space is a three-dimensional continuum containing position and direction in classical physics. Physical space is often conceived in three linear dimensions, although modern physics usually considers this time to be a part of bounded four-dimensional. Seeing the poster, have imagination moves take to me. Our mind is like a parachute. If it open, it doesn't work. Astronauts saved from moon. When I first looked at parachute here, dead standing on the moon like right. Thank you, ma'am.
Lot number 33, your time, sir. Murshida Shirin, please mute your mic. Lot number 34, Needhi Valavan. Lot number 34, Needhi Valavan, are you there? Lot number 34, Needhi Valavan. Lot number 35, Saumya. Lot number 35, Saumya.
Yes, ma'am.
Your time starts.
Yes, ma'am. Good morning, myself Soumya. Today I am going to talk about this topic, physics in space. In our Earth, unknown observable universe contains lots of mysteries. We unlocked so many mysteries like how the universe created in the name of Big Bang Theory. We are unlocking so many mysteries like nebula to black hole, which is the life cycle of star. We will unlock so many mysteries like quantum teleportation, dark energy, dark matter, antimatter, etc. by using the key called physics. It is all done because of the curiosity of mankind to unlock all the mysteries. The technology in physics gave the images like pillars of creation, Eagle Nebula, which is called cosmic glyphs, seeming three-dimensional pictures, which is given by James Webb Telescope, which takes the world into next era by finding how we created, how we birth, and by continuous evolution in technology in physics, that is physics in space. That's why we are trying to use physics not only to understand where we are living, but also where we come from. Thank you, ma'am.
Thank you, Soumya. Lot number 36, Rupa, are you there? Lot number 36, Rupa. Lot number 36, Rupa, are you there? Lot number 37, yes, Tanush. Lot.
Excuse me, ma'am, 1 minute, ma'am. 36 ரூபா பேசுறது கேக்கல மேம். சேம் காலேஜ் மேம். அவங்க பேசிட்டு இருக்காங்க பட் கேக்கல மேம்.
Okay, then starts your presentation.
மேம் ஏன் எக்ஸ்பிளைன் மட்டும் என் ஃபோன்ல பண்ண சொல்லட்டுமா மேம்? ரூபா
ஓகேடா, கண்டினியூ பண்ணுங்க.
ஓகே மேம்.
Hello, ma'am. Hello.
Rupa, your time starts now.
Thank you, ma'am. I'm Ruba from Valluvar College. First எல்லாம் வந்து மேம் ஃபர்ஸ்ட் எல்லாம் வந்து உலகம் வந்து தட்டையானது, சூரியன் தான் பூமியை சுத்துது அப்படிங்கிற ஒரு அசம்ஷன் இருந்தது. டெலஸ்கோப் வந்து நம்ம இன்ட்ரடியூஸ் பண்ணதுக்கு அப்புறம் தான் உலகம் வந்து கோள வடிவம், பூமி தான் வந்து சூரியனை சுத்துது அப்படிங்கறத வந்து நம்ம தெரிஞ்சுக்கிட்டோம். ஹான்ஸ் லிப்பர்ஸி அப்படிங்கிறது 1608 வந்து டெலஸ்கோப்பை வந்து ஃபர்ஸ்ட் உருவாக்குனாரு. கலிலியோ வந்து அதை ஸ்பேஸ்ல வந்து யூஸ் பண்ணாரு. இது வரைக்கும் வந்து ஸ்பேஸ்ல வந்து எண்ட் பாயிண்ட் அப்படின்னு ஒண்ணு வந்து இல்லவே கிடையாது. ஸ்பேஸோட எண்ட் பாயிண்ட் ஒண்ணு இல்லவே கிடையாது. ஃபியூச்சர்ல வந்து என்ன கண்டுபிடிப்போமா அப்படின்னு தெரியல. ஏன்னா நம்ம ரிசர்ச் என்னதான் பண்ணாலும் வந்து நம்ம ஸ்பீடோட ஸ்பேஸ் வந்து எக்ஸ்பேண்ட் ஆயிட்டே போயிட்டு இருக்கு. ஐன்ஸ்டீன் அப்படிங்கிறவர் வந்து ஈக்குவல் டு MC ஸ்கொயர் அப்படிங்கிற ஒரு ஃபார்முலா வந்து நமக்கு தந்திருக்காரு. நிறைய கான்செப்ட்ஸையும் வந்து இன்ட்ரடியூஸ் பண்ணவர் ஐன்ஸ்டீன் தான். இவரை வந்து ஃபாதர் ஆஃப் பிசிக்ஸ் அப்படின்னு கூட நம்ம சொல்லலாம். நெக்ஸ்ட் நாசா வந்து இந்தியாவில் வந்து ரிசர்ச்ல வந்து நம்ம 6th பிளேஸ்ல இருந்தாலும் மார்ஸுக்கு வந்து சேட்டலைட்டை அனுப்புனது, இந்த மாதிரி இதில் வந்து நம்ம தான் வந்து ரொம்ப வந்து ஆர்வமா இருக்கும் ரிசர்ச்ல. ஸோ the கான்செப்ட் என்ன அப்படின்னா வந்து எவ்ரி கியூபிக் இன்ச் ஆஃப் ஸ்பேஸ்.
Lot number 36, Rupa.
Yes, sir.
Your time's up. Your time's up.
Thank you, ma'am. Thank you, ma'am.
Lot number 30. Lot number 37, yes, Tanush.
Yes, ma'am.
Lot number. Your time starts
Yes, ma'am.
now.
Okay. Good morning to all. I am S. Dhanush. I am insert the poster of the topic is some basic physics theories. First, we met the Einstein. Einstein's the famous line: education is not the learning of facts, but the training of the mind to think. He told the E is equal to MC square. In physics, mass energy equivalence is the relationship between mass and energy in a system's rest frame, where the two quantities differ only by a multiplicative constant and the units of measurement.
Tanush.
This principle is described by the yes, ma'am.
Lot number 37, Tanush. One second.
Yes, ma'am.
Murshida Shirin, please mute your mic. Murshida Shirin. Tanush, you continue.
Okay, thank you, ma'am. This principle is described by the physicist Einstein. His famous formula is equal to MC square. Next, we met the Newton. Newton, he told 3 laws. First law, an object will not change its motion unless force acts on it. He said that the second law in the force on the object is equal to its mass time its acceleration. In third law, when two objects interact, they apply forces to each other of equal magnitude and opposite direction. Thank you, ma'am.
Thank you for your presentation. Lot number 38, yes, Bharati Raja. Lot number 38, yes, Bharati Raja.
Ma'am, Bharati Raja, ma'am.
Bharati Raja.
Hello, ma'am. Ma'am, yes, Bharati Raja, ma'am. Hello.
Start. Lot number 38, yes, Bharati Raja. Your time starts now.
Hello, everyone. Yes, Bharati Raja from Barrier Basic Physics from Srimad Andavan. Today topic is the astrophysics. Astrophysics is a branch of space science that applies the law of physics and chemistry to seek to understand the universe and the space it is in. The field explores topics such as the break light and death of the star, planet, galaxy, neighbors, and other objects in the universe. Astrophysics creates the physical theory.
Lot number 8, Farron Jules.
Yes, present here.
Lot number 9, Electrics. Lot number lot number 10, beta Libre.
Yes, ma'am.
ஹலோ ஹலோ ஏங்க சீக்கிரம் முடிங்க, அடுத்து குஸ்டின் ஈவெண்ட்டுக்கு போகணும்.
Once again, congratulations to the top 10 teams. Now, I'm going to explain the instructions for the round 2. The round 2 contains 3 levels. Level 1 is connection. We will display some images. You have to connect the pictures. Each team is asked one question, and the duration for each question is 30 seconds. Each question carries 20 marks. If you are not answered the question within the stipulated time, the question will be passed to the remaining teams as an open choice question. The remaining teams have to answer for that question within 15 seconds. The team which answered first will get 5 credit points. Are you clear with the instruction?
Yes, ma'am.
Okay. இப்போ ஃபர்ஸ்ட் டீம் எந்த டீமுக்கு கீப் 10 டாட் நம்பர் 10. மைக் ஆன்ல தான் இருக்கு. Lot number 10, be ready. While answering the question, please unmute. Question. Lot number 10. This is your question. Find the circuit name. And your 30 seconds time starts now.
Amplifier. Hello, ma'am.
Please tell the full answer.
Amplifier.
Wrong answer. Now the question is passed to the remaining teams as an open choice question. The team which knows the answer can put your answer in the chat box.
Class A amplifier.
Please put it in a chat box. Arish, please tell your lot number.
Yeah, we are from lot number 3.
Okay, thank you. Lot number 9. Your time is up. Now the pass to the remaining teams. You can answer in the chat box and put your lot number along with the answer. You put your answer along with your lot number. Time is up.
Please, கேக்குதா?
மேம் டைம் ஸ்டார்டிங் டைம் அப் மட்டும் சொல்றீங்க.
The time will the time will the time will start immediately after the question is asked. Now the question is for lot number 8, Farah. And your question is? Find the scientist's name.
Ma'am, excuse
and the time
me, ma'am,
starts now.
excuse me.
Slide என்ன வரல மேம்.
Excuse me. Excuse me, ma'am. Ma'am, am I audible? Yes. Yes, ma'am. Previous question க்கு யார் வின்னர்னு சொல்லல மேம். யாருக்கு பாயிண்ட்ஸ் கொடுக்குறீங்கன்னு சொல்லல மேம். No points. No points for anything. Okay.
Excuse me, எனக்கு ஸ்லைடே வரல.
Okay. Please wait for a minute. Now, the question is for the lot number 8, Farah Jules. And your time starts now.
Benjamin Franklin.
Is right answer. Now, the question is for lot number 7, lunar rovers. And your time starts now.
Microprocessor.
Is correct answer. Now, the question is for lot number 6, optimal circuits. And your question is? Ma'am, frequency modulation. Correct answer. Now, the question is for lot number 5, victorious. And your question is? Time up, and the question is now passed to the remaining teams. The team who knows the answer can put it in chat box along with your lot number. Lot number 3, your answer is correct.
Thank you.
Now the question is for lot number 4, copper nickels, and your question is time up. Now the question is passed to the remaining teams. You can answer. Lot number 3, your answer is correct.
Thanks again.
Now the question is for lot number 3, energetic worms, and your question is time up. Now the question is passed to the remaining teams. You can answer in chat box. Lot number 2, your answer is correct. Now the question is for lot number 2, wings of fire, and your question is
Full width half maximum.
right answer. Now the question is for lot number 1, rookie rockers, and your question is
Boolean algebra.
right answer. Now the first level is completed. Now move on to the level 2. In the level 2, the pictures or videos with the relevant question will be displayed in the screen. Duration for this level is 1 minute. You have to give the relevant concept for the given question. This question has no pass to the remaining teams. The question will not be passed to the remaining teams. For example, the demo question is, here is some picture. What principle is used to make an immersion heater work? The answer is, once plugged into the power source, the heating coil starts to warm up, transferring the heat to the water. The heating element of the rod convert the electric energy into heat and pass it on to the water. This ensures steaming hot water ready for any purpose. You need not to tell like this paragraph. If your answer is close enough, we will take it into our consideration. After 30 seconds, we will give you a hint. The time duration for this level is 1 minute. After 30 seconds, we will give you a hint. Participants, are you clear with the instruction? Participants, you have any doubt? If no, then go to the level 2. Now, ready, lot number 10, beta Libre, and your question is? Look at this video. Look at this video and tell what is wrong and what is fake in this video. What is the physics phenomena behind it?
Just to be clear, take a careful look at this GIF file, or this GIF here. This is a fake video. What we want you to do is give us any 2 reasons why this is fake. And if your 2 reasons are short and they're good enough, you'll be given marks. You have 1 minute to answer. After 30 seconds, we will give you. Your time starts now. Okay, if you're struggling, the hint is imagine how a magnetic generator would work and look at this video and tell me what's wrong with this magnetic generator here and why it cannot charge a phone like this. If you at least try to attempt to say something, you might get marks. Okay, time's up. The answer is, so there are several reasons why this is wrong. If you had said any 2 of them, you would have gotten marks. So obviously, mobile phones require a DC to charge, and an inductance coil here will only produce AC. On top of it, the magnetic field is not cutting through the coil at all, so it won't produce enough electric current or enough AC to produce, and you need more number of coils. And the motor doesn't, which is rotating the magnet, doesn't seem to slow down at all under the charging load. So there are several reasons why this is fake. But of course, the clue being that it's a magnetic generator, you shouldn't be able to answer it. Anyways, we'll move on to the next question. This is for lot number 9. So it's a very simple question. You have a battery which is supplying a constant voltage, and suppose if I'm connecting a load resistance to it, if I measure the resistance across that, if I measure the voltage across that resistance, the battery voltage drops. Why does it drop? What is the reason behind it? Starts now. Yes.
The voltage above.
Go ahead.
This drop in voltage is caused by the internal resistance of the battery.
Caused by the
Internal resistance of the battery.
That's correct. That's correct answer. It's due to the internal resistance. It will create, there's an internal resistance of the battery, which will create a voltage divider circuit, and it will divide the voltage, and hence you'll have a drop in the voltage. Correct answer. You get full marks.
Thank you, sir.
Okay. Yeah, next question is for lot number 8, Far and Joules. So you have there's a YouTube video which shows that you have a capacitor like this, and if I connect a DC across a capacitor, the capacitor blocks the DC. But if I connect AC across the capacitor, the AC circuit, the charges flow through it, passing through the capacitance very easily. Now, is this right or is this wrong? If this is right, why is it right? If it's wrong, why it's wrong? It's simply one word, one sentence or two sentence explanation. Your time starts now.
Sir, once fully charged the capacitors will stop allowing any more electrons to reach the plates. So does the capacitor stop DC once it's fully charged?
Okay, what about AC?
When we add AC voltage, the capacitor will charge and discharge at some frequency.
Okay. So what the YouTuber said is right or wrong? This diagram correct or wrong?
This diagram. Yes. Yes.
Okay, your answer is right. Your answer is right, but your reasoning is wrong. But we'll give you marks.
Yes, this image.
Thank you, sir.
The answer is right. Basically, when you connect DC, it charges up to a certain voltage and it stays there. With AC, it charges and discharges continuously. Next question for lot number 7. So your capacitors included with AC motors and transformers in industries and are connected in as shown there. Why do you think they connected, and what do you mean by improving the power factor? This is for lot number 7. I'll give you a hint. Think of real power and apparent power. Think of inductance and capacitance lagging and leading voltages. That effect, that physics works here. So based on that, why do you think, what is the logic behind connecting capacitors like this parallelly across inductors?
Capacitors are generally used to improve the power factor and minimize energy wastage.
Okay.
Reducing reactive power by improving the power factor of an AC load helps to minimize the overall cost of running the industry.
Yes, but why is it doing it here? What is the physics behind it? Okay, your time's up. Yeah, okay, go ahead. Go ahead.
To reduce the power, we generally use capacitors.
Okay, well, the answer is wrong, but the correct answer is basically a capacitor, it leads the voltage, and inductor lags behind the voltage. So if you connect a capacitor with an inductor, it cancels out that apparent power, and most of the power consumption is across the voltage itself. And so you won't have leading and lagging effect happening in LC circuits like this. So no marks for that. We'll go on to lot number 6. Your next question is, so you have something like called as a TVS diode here. You don't need to know exactly what a TVS diode is, but this is a circuit of an inverter. Now what happens is, this is a very high power circuit. So if I connect something in reverse, meaning if I connect any device, very high power device in reverse, meaning instead of negative I connect positive and positive I connect negative, reverse the polarity, the fuse will blow and it will damage the circuit, right? So why do you think that they connect diodes like this, or a TVS diode? You don't need to know what the diode does, but why do you think they connect a diode like this for reverse polarity protection, so that the device doesn't blow up? What is the reasoning behind connecting a diode like that? Lot number 6 is your question.
Sir, TVS diodes
Observe normal voltage from interference.
No. Okay, we'll give you a clue. The clue is, imagine the diode. The diode acts as a clamping voltage, meaning it will restrict the voltage from going beyond a certain value. So in that regard, tell me what happens.
So to protect against automatic high energy negative transits generated from disconnection of supply from inductive loads.
No, that's not the right answer. The correct answer is the diode basically blocks very high voltages from entering the circuit, as it clamps just like a Zener diode, it just clamps the voltage at a certain value so that it doesn't go for higher voltages and doesn't damage the circuit. Next question for lot number 5. It's a very simple question. What is the basic difference between a microcontroller and microprocessor? Any two differences should do it. Any two differences. Lot number 5.
A microprocessor is a processor where the memory and input components are connected externally. A microcontroller is a controlling device wherein memory and input-output connected.
Yeah, go ahead.
External connection.
Okay, any other differences?
Okay, 1 minute, sir.
Your time's up. I'll give you, I won't give you full marks, but I'll give you a few half mark for half the allotted marks because at least you gave one difference. We'll go to the next question. There are several differences. Of course, one of which you mentioned memory is there, but of course, more than that, it performs faster and microprocessor is a lot more slower, microcontroller is faster, but generally speaking, microprocessors are more diverse. They have most for wide variety of applications, while microcontrollers are very specific. So lots of differences like this. We'll go on to the next question. Lot number 4. Lot number 4. Okay, you have a red LED, and if I'm shining an LED bulb, another LED bulb onto that red LED, what is happening is it's generating a voltage across the red LED. Why do you think that happens? And if I replace the red LED with the blue LED, there is no voltage generated across the blue LED if you shine a light on the blue LED. LED emits light, but it can also, it can also generate voltage when light falls on it. Why do you think that happens? And why it has a very reduced effect when you replace red with blue LED?
Red LED has higher wavelength. Blue has a lower wavelength.
Okay, that's okay, but what is the answer? Why does it do that? Because of that. First, why does it generate LED voltage in the first place? Okay, your time is up. The answer is LEDs generate current because of the flow of electrons. Flow of electrons when light falls on it. Basically, any diode does that. But the reason why LED is more susceptible to doing that is it's much more sensitive to a wavelength lesser than that. That's a general property of LED. While blue has a very less, it doesn't have a lot of lights that is falling on it that's lesser than that in wavelength. Hence, you will have red LED performing much better than blue LEDs in this regard when generating, when acting as a photodiode. Let's move on to lot number 3. what is the advantage of a 555 timer over any other high frequency clock circuits? What is the advantage in the sense, instead of that, you can just say the difference between a 555 timer and other clock circuits. What is the difference? Since we don't have a lot of time, I will not be going for a lot of explanations. So either I'll just say your answer is right or wrong. I'll just be showing you the slide the answer is in, moving on to the next question.
Excuse me.
Yes, go ahead.
555 timer ICs are used to generate different kinds of waveforms at once, like sine, triangular, and square waves, and their output are a little bit less noisier than other clock circuits comparatively. And do you expect any other kind of parameters?
Okay, that's also correct. But what we had majorly mentioned was, I'll give you marks for that. That's actually correct. But what we majorly mentioned was that we can majorly mention is that we can control the clock pulses much better. How faster, especially in terms of applying it to microprocessors and microcontrollers, when trying to test them out, it's better to use 255 times over any other clock pulses.
We can use some resistor and capacitor combination in controlling the 555 IC's output.
Yes, we can, of course. But that's the main reason. But of course, your answer is also valid. I did not mention it here, but we'll consider it as a valid.
Okay. Thank you.
Yeah. To note number 2. What is convolution?
Convolution is when some operation is performed on two functions, and there will be a third function which shows how the shape is modified by the other. So basically, it is an integral that expresses the overlap of one function over another function.
Okay, I can give you half marks for it, but you still have time. Can you be a little bit more specific?
Kind of answer, like what kind of
if I were to give you a clue in terms of digital signal processing, FFTs, fast Fourier transforms, how will you apply?
Okay. So basically, in Fourier transform, we use convolution where two functions in real space is the same as the product of their respective Fourier transforms.
Okay, I can accept that as an answer. I'll give you marks, but I've given you a clue, so reduce marks.
Okay, thank you.
So we'll move on to the next question. Lot number 1 is your question. In an ideal op-amp circuit like this, so it's a non-inverting amplifier like this, why does it amplify? Why does it amplify the input voltage? We know it does amplify, but what is the condition it needs to amplify input voltage? What condition must it satisfy to do that?
ஓபன் லூப்ல கெயின் அதிகமா இருக்கும். இந்த மாதிரி ரெசிஸ்டன்ஸ் வைக்கும்போது கெயினை நம்ம கண்ட்ரோல் பண்ணலாம்.
Yes, the gain will be more. That's basic, but exactly why? What condition must satisfy the input end? I'm giving you a clue. What condition must it satisfy the input end for it to amplify? Look at the two positive and negative inputs, or the inverting and non-inverting inputs. What condition must they satisfy for it to, amplify it in the first place? I've given you a biggest hint possible.
The voltage difference between the input and output. Input and
output. Yeah, input and output should be. Go ahead. Hello.
இது ரெண்டையும் டிவைட் பண்ணா இன்புட் அண்ட் அவுட்புட் டிவைட் பண்ணா கெயின் வந்து அதிகமா இருக்கு.
Not exactly. You won't get marks for that. You're close enough, but you're not exact with the answer, so I won't give you marks. The answer is simple. The inverting, the voltage difference between inverting and non-inverting has to be zero. That's it. It's a very simple answer. So as long as it's zero, based on that, your gain will always be based on your. Of course, it will also depend on your resistors, but it will amplify it in the first place mainly because it has to maintain that zero voltage difference between input and inverting and non-inverting. No, you did not say that. That was not your exact words. Those are not your exact words.
Okay.
You didn't mention to be zero, so can't give you marks for that. But anyways, good attempt. We'll move on to the next level. For that will be a final level, and based on this, we'll be accumulating. We'll be considering your cumulative total and be ranking you based on who performed the best. So we'll hand over to for the next one.
The instructions for the level 3 is the circuit will be displayed in the screen. You have to find the errors in the circuit. The duration for this level is 30 seconds. If you need any hint will be given. Sorry, the hint will not be given for this level. This level contains no past questions.
Excuse me, ma'am.
Yes.
How much points it holds?
20 points. Level 3 has 20 points. Now, the question is for lot number 10. You have to find the error in the circuit. Please note that your time is 30 seconds.
The circuit C is not connected. The circuit is wrong.
Yeah, you have to mention which is wrong in the circuit. The exact point.
The circuit C la connect ஆகாம இருக்கு.
Yes, your answer is right. Now, the next question for lot number 9. And your time starts now.
No issue.
Ma'am, it's the correct circuit. No error.
Sorry, repeat. No, it has error. You have to mention it. The circuit has an error. Sorry, your time is out. The answer is now the next question for lot number 8. And your time starts now.
சி இன்புட் கொடுக்கவே இல்லை மேம்.
Yes, your answer is right. Yes, your answer is right. Now the question is for lot number 7. And your time starts now.
The equation has addition, but the OR gate is not present.
Please repeat.
The equation has addition, but the OR gate is not present.
Correct. Your answer is right. Now the question is for lot number 6. And your time starts now. Your time is up. And the answer is now the question is for lot number 5. And your time starts now.
மேம் டாட் கேட் கனெக்ஷனே இல்லாம இருக்கு மேம்.
Yes, your answer is right. Now the question is for lot number 4. And your time starts now.
Capacitance is wrong. Resistance wrong.
Please repeat.
C1 கிட்ட resistance வரும்.
Correct. Your answer is
for other resistance.
Yes, your answer is right. Now the question is for lot. Now the question is for lot number 3, and your question is, and your time starts now.
The capacitor
Your time
should
is
be
up.
connected. Yes, ma'am, I am with the answer. The capacitor should
Sorry,
be
your
connected.
time is up, and the answer is.
But ma'am,
Now the question
we
is
are
for
about to
lot
say
number
the,
2.
ma'am, excuse me, we are about to say the answer. The capacitor
okay.
is wrong. That was what I was saying. When I was saying that capacitor was wrong, you stopped me.
The capacitor and
Okay, sir. Okay, sir. We are
should be connected
considered.
with
We are
the parallel.
considered.
Yeah.
Thank you.
Now the question is for lot number 2.
The diode and the resistor should be interchanged.
Yes, your answer is right. Now the question is for lot number 1, and your time starts now.
பிளஸ் மைனஸ் மாறி இருக்கு மேம். பாசிட்டிவ் நெகட்டிவ் டெர்மினல் இன்டர்சேஞ்சா இருக்கு மேம்.
Sorry, wrong answer. You still have 20 seconds. You can find the correct answer.
கிரவுண்ட் ஆயிருக்கு மேம். கெபாசிட்டர் அண்ட் ரெசிஸ்டர் வந்து இன்டர்சேஞ்ச் ஆயிருக்கு மேம்.
Yes, your answer is right.
தேர்ட் டீம் நீங்க ஆன்சர் வந்து டிலேயா சொன்னீங்க, அதனால உங்களுக்கு நாங்க பாயிண்ட்ஸ் கன்சிடர் பண்ணுவோம். ஆனா பாயிண்ட்ஸ் வந்து நாங்க வந்து மைனஸ் பண்ணுவோம், கொஞ்சம் ரெடியூஸ் பண்ணுவோம். ஓகே, உங்களுக்கான பாயிண்ட்ஸ் கன்சிடர் பண்றோம் நாங்க.
For which team, ma'am?
தேர்ட் டீம், லாட் நம்பர் 3.
Okay, fine. Thank you.
Teams, thank you for your enthusiastic participation.
Dear participants, pay your attention, please. Team Victorious, Optimal Circuits, Pharyngeals, Beta Libre, Copernicus, Electrics, and Revant Kumar from Energetic Worms. You are requested to join QuizBiz, and the link for the game is displayed in the chat box. And thanks for your participation. Other teams can leave the meet. Results will be intimated later. Thank you. Thanks for your participation.
Excuse me.
Yeah, yes.
Ma'am, first roundல team 9க்கு அந்த கனெக்ஷன் ரவுண்ட்ல என்ன ஆன்சர் ஹார்ட்லி ஆசிலேட்டர் காமன் டு ஆன்சர் சொன்னீங்க மேம். பட் அதில் நாங்கள் ஃபர்ஸ்ட் நீங்கள் நாட் கன்சிடர்னு போட்டீங்க. பட் அதுக்கு முன்னாடியே நாங்கள் ஆன்சர் அதில் சாட் பாக்ஸில் போட்டோம். ஸோ நீங்கள் செக் பண்ணீங்கன்னா
சாட் பாக்ஸ்ல சொல்றதுக்கு முன்னாடி நீங்க மைக்க வந்து ஆன் பண்ணி சொல்லிட்டீங்க. நாங்க வந்து சாட் பாக்ஸ்ல தான் போட சொல்லியிருந்தோம்.
இல்ல மேம், நீங்க ஆஃப்டர் அவங்களுக்கு நீங்க டைம் ஆப்ஷன் சொன்ன அடுத்த செகண்ட் போடுவாங்க. அதுக்கு அப்புறம் தான் இன்னொரு டீம் போட்டுருக்காங்க. நீங்க அதை செக் பண்ணி சாட் பாக்ஸ்ல பார்த்தா தெரியும். சோ ப்ளீஸ் கன்சிடர் அபௌட் தட்.
எக்ஸ்கியூஸ் மீ,
நீ பேசுற மேம்.
உங்களுக்கு கேக்குதா பேசுறது?
மேம் ரொம்ப லோவா கேக்குது.
நீங்க வந்து நாங்க வந்து ஸ்டார்டிங்லேயே சொல்லியிருந்தோம், சாட் பாக்ஸ்ல தான் பாஸ் கொஸ்டினுக்கு வந்து ஆன்சர் பண்ண சொல்லி. நீங்க மைக் ஆன் பண்ணி சொல்லிட்டீங்க. ஸோ ரூல்ஸ் பிரேக் பண்ணனால அதை நாங்க கன்சிடர் பண்ணல.
இல்ல மேம், மைக் ஆன் பண்ணல நாங்க. நீங்க அதை ஆஃப்டர் டைம் ஆப்ஷன் சொன்ன அடுத்த செகண்ட் நாங்க சாட் பாக்ஸ்ல போட்டோம். எங்களுக்கு நாங்க போட்ட அரசு இன்னொரு குரூப் போட்டிருக்காங்க அதுல. ஸோ நீங்க அதை கன்சிடர் பண்ண மாட்டோம்ட்டீங்க. பட் நாங்க மைக் எதுவுமே ஆன் பண்ணல நாங்க. அதுக்கப்புறம் தான் சாட் பாக்ஸ்ல போட்டோம். அந்த ஹார்ட்லி ஆசிலேட்டர் நீங்க சாட் பாக்ஸ் செக் பண்ணீங்கன்னா அதுல போட்டிருக்கோம். ஸோ ப்ளீஸ் ரீகன்ஃபார்ம் தட் மேம்.
Sir, can you please contact the help desk for further clarifications? And நான் அனௌன்ஸ் பண்ண டீம்ஸ் சீக்கிரமா கொஞ்சம் குவிஸ் பிஸ் ஓட லிங்க் வந்து நாங்க சாட் பாக்ஸ்ல போடுறோம். நீங்க சீக்கிரம் ஸ்டார்ட் பண்ணிக்கோங்க. பிகாஸ் அந்த டீம் வந்து உங்களுக்கு வெயிட் பண்ணிட்டு இருக்காங்க. ஸோ ப்ளீஸ் லாகின். யா ஷூர்.
ஓகே மேம், நாங்கள் அதை லாகின் பண்ணுறோம். இந்த ஹெல்ப் ஏதோ சொன்னீங்க, அது எப்படி மேம்?
யா ஹெல்ப் டெஸ்க்கு வந்து நீங்க காண்டாக்ட் பண்ணிக்கோங்க. அந்த நம்பர் வந்து உங்களுக்கு இதுக்கு டிஸ்ப்ளே ஆயிருக்கும். ஓகேங்களா? ஸோ நீங்க அவங்க கிட்ட வந்து queries வந்து கேட்டுக்கோங்க. ஸோ நெக்ஸ்ட் ஈவெண்ட் வந்து நீங்க சீக்கிரமா போய் ஜாயின் பண்ணுங்க.
ஓகே
அந்த டீம் வெயிட் பண்ணிட்டு இருக்காங்க. ஓகேங்களா?
ஓகே மேம், ஓகே மேம், ஓகே மேம், தேங்க்யூ மேம், தேங்க்யூ.
யா
மேம் லாஸ்ட் நம்பர் ஒன் ஒரு டவுட் மேம். மேம்
எஸ்
மேம் ப்ரிலிம்ஸ் பாயிண்ட் இதுல கன்சிடர் பண்ணிக்கிறீங்களா மேம்?
உங்க டைம் அந்த மினிட்ல இருந்து ஸ்டார்ட் ஆகும். Participants who are joined now, kindly enter your lot number and team name in the chat box.
Excuse me, ma'am. Hello? Hello? மேம் ஃபில் இன் த பிளாங்க்ஸ்ல ஒரு கொஸ்டின் மாதிரி இருக்குன்னு சொன்னா அதுக்கு வந்து நாங்க ஃபுல் நேம் தான் டைப் பண்ற மாதிரி இருக்குமா இல்ல என்ன மாதிரி மேம் வச்சிருக்கீங்க? கேப்ஸ்ல மட்டும் தான் அக்செப்டட், இல்ல ஃபுல் நேம் வேணுமா இல்ல ஒரு கீ ஹிண்ட் போட்டாலே போதும்? உங்க வாய்ஸ்
நீங்க எந்த செக்ஷன்ல கேக்குறீங்க? ஃபர்ஸ்ட் செக்ஷனா செகண்ட் செக்ஷனா? கூகுள் ஃபார்ம்ஸ்ல தானே கேக்குறீங்க?
ஆமா, ஐடென்டிஃபை தி பிசிசிஸ்ட்னு ஒரு போட்டோ இருக்குல மேம்.
அதுக்கு வந்து நீங்க ஃபுல் அந்த சயின்டிஸ்டோட நேம் உங்களுக்கு தெரியறத போடுங்க.
ஃபுல் நேம் போடணுமா மேம் இல்ல கேப்ஸ் ஸ்மால் அந்த மாதிரி ஏதாச்சும் இருக்கா மேம்? என்ன மேம்?
நெசசரி இல்ல, நீங்க எப்படி வேணா போடலாம்.
ஓகே ஓகே.
நெசசரி இல்ல மட்டும் ஃபார் எக்ஸாம்பிள் ஆல்பர்ட் அவசியம் இல்ல. ஓகேங்களா? கூகுள் ஃபார்ம்ஸ் லிங்க் வந்து திரும்ப போஸ்ட் பண்ணியிருக்கோம். எலக்ட்ரிக் ஃபியூஷன்லேருந்து வந்த பார்ட்டிசிபென்ட்ஸ் இப்போது நீங்கள் லாகின் பண்ணலாம். இப்போலேருந்து உங்களுக்கு 20 minutes டைம் எடுத்துக்கலாம் நீங்கள். எலக்ட்ரிக் ஃபியூஷனில் பார்ட்டிசிபேட் பண்ணிட்டு வந்தவங்களுக்கு மட்டும்தான் இந்த ரெஷர் டைம். மற்ற பார்ட்டிசிபெண்ட்ஸ் 12:15க்குலாம் நீங்கள் வந்து சப்மிட் பண்ணிடணும். லேட் சப்மிஷன் இஸ் நாட் அப்ரிஷியபிள்.
எக்ஸ்கியூஸ் மீ மேம்.
சொல்லுங்க
மேம், இமெயில்ல இது கூகுள் ஃபார்ம் லிங்க் வரவே இல்லை மேம்.
கூகுள் ஃபார்ம் லிங்க் வந்து இங்கே சாட் பாக்ஸில் போட்டிருக்கோம்.
சரி, ஓகே மேம்.
எலக்ட்ரிக் ஃபியூஷனில் இல்லாத பார்ட்டிசிபெண்ட்ஸ் மற்ற பார்ட்டிசிபெண்ட்ஸ் எல்லாருக்கும் இன்னும் 5 minutes டைம் இருக்குது உங்கள் கூகுள் ஃபார்ம்ஸை வந்து சப்மிட் பண்ண. லேட் சப்மிஷன் இஸ் நாட் அப்ரிஷியேட்டட். எலக்ட்ரிக் ஃபியூஷன்ல இருந்து வந்த பார்ட்டிசிபென்ட்ஸ் தவிர மற்ற எல்லாருக்கும் ப்ரிலிம்ஸ்க்கான டைம் இஸ் ஓவர். இதுக்கு மேலே சப்மிட் பண்ணுறவங்களது வி வில் நாட் இவாலுவேட். எலக்ட்ரிக் ஃபியூஷனில் பார்ட்டிசிபேட் பண்ணிட்டு வந்த பார்ட்டிசிபென்ட்ஸ் உங்களுக்கு இன்னும் ஒரு 10 minutes டைம் இருக்குது. ஸோ டூ குயிக்.
எக்ஸ்கியூஸ் மீ. ஹலோ,
சொல்லுங்க.
எக்ஸ்கியூஸ் மீ.
சொல்லுங்க.
நாங்க வந்து கொஞ்சம் நெட்வொர்க் இஷ்யூனால ஒரு 1 minute லேட்டா சப்மிட் பண்ணிருக்கோம். இஸ் தட் an issue?
நோ ப்ராப்ளம்.
நீங்க சொன்ன உடனே சப்மிட் பண்ணிட்டோம்.
ஓகே ஓகே, வில் டூ.
தேங்க் யூ.
மேம்
சொல்லுங்க.
எக்ஸ்கியூஸ் மீ.
சொல்லுங்க.
2 மணிக்கு வரும். 2 மணிக்கு பஸ்ல போயிட்டு இருப்போம். போன் அடிக்கிறேன்.
கைண்ட்லி அன்மியூட்.
மேம் எங்களுக்கு கூகுள் ஃபார்மே லேட்டா தான் மேம் வந்துச்சு. இன்னும் கொஞ்சம் டைம் வேணும் மேம்.
நீங்க எப்போ ஜாயின் பண்ணீங்க?
கொஞ்சம் லேட்டா தான் மேம் வந்தோம். நான் கூட உங்கள்ட்ட கேட்டேன்ல மெயில்ல இது வரல, என்ன கூகுள் ஃபார்ம் வரல.
ஆக்சுவலி சரி பண்ணுங்க, இன்னொரு 5 minutes சப்மிட் பண்ணுங்க.
ஓகே மேம், தேங்க்யூ மேம்.
எலக்ட்ரிக் ஃபியூஷனில் பார்ட்டிசிபேட் பண்ணிட்டு வந்த பார்ட்டிசிபென்ட்ஸ் யூ ஹவ் ஒன்லி 5 more minutes.
கேட்டேவா உள்ள போயிட்டு
A gentle reminder, participants kindly avoid unnecessary disturbance or any noise during the event. Tirumalai Kumaran, any queries? Tirumalai Kumaran, any queries? Okay. Electrocutionல இருந்து வந்த participants, you have hardly just 2 more minutes. Late submission is not appreciated. Participants, we are going to of the response for the Google Forms. Kindly submit. Participants kindly note we have off the response for the Google Sheets for all the participants. Within 5 minutes, we will tell the shortlisted participants for the second round. Participants kind attention. We are going. We will give the shortlisted participants list very shortly. The shortlisted participants for the advanced round are lot number 49, Beta Libre, lot number 27, Lunar Rovers, lot number 48, Farhan Jules, lot number 46, Victorious, lot number 8, Rookie Rockers, lot number 28, Everlasting Eclipses, lot number 64, Awesome Aliens. I repeat, lot number 49, lot number 27, lot number 48, lot number 46, lot number 8, lot number 28, lot number 64. We congratulate all the other participants. The participants list are displayed in the chat box for your convenience. The shortlisted participants are asked to join the next meet for the advanced round. The meet link will be sent to your respective mail IDs. Both the participants are requested to join in the same device. Thank you. The shortlisted participants will receive their Google Meet link for the advanced round very quickly through their email. Kindly check the email both in spam and inbox.
Hello, ma'am. Excuse me, ma'am. Am I audible? Mail என்ன link வரல ma'am. தான் சொன்னேன். ஹலோ மேம், எக்ஸ்கியூஸ் மேம், லிங்க் மெயில் வருமா இல்லை கூகுள் மீட் சென்ட் பண்ணுங்க.
ஹலோ மேம், கேக்குதா? ஹலோ மேம்.
லாட் நம்பர் 49 இருக்கீங்களா? லாட் நம்பர் 49. லாட் நம்பர் 49.
இருக்கோம் மேம்.
ஓகே. லாட் நம்பர் 27. லாட் நம்பர் 27. Lunar rovers. Okay. Lot number 48.
Yes, ma'am.
Lot number 46. Lot number 46.
Yes, ma'am.
Lot number 8.
Yes, ma'am.
Lot number 28. Lot number 28. Lot number 64. Awesome aliens.
Yes, ma'am.
Okay.
Yes, ma'am.
Just we can wait for a couple of minutes. Still one participant didn't join the meet. We can wait a couple of minutes. A very thoughtful Thursday to one and all present here in this virtual meet on behalf of the entire team of Apeiron 2K23 and the Department of Physics, Bardhasan University. Extend a very warm welcome to all the participant friends from various institutions for your active participation in this Masters Quiz event by the name Quiz. Once again, I welcome all the shortlisted participants to this advanced round. I wish you all a very good luck, guys. So, the mains is going to have 3 rounds. The first round will be hide and seek, and the second round is a challenge to your skill, and the third round is a rapid fire. I repeat, in the mains, the first round is going to be a hide and seek round, second round is a challenge to your skill, and third round is a rapid fire round. Now it's time to play hide and seek. The rules and regulations for this round is that the pictures of well-familiar physicists will be displayed, but it will be in blurred manner. The duration for answering a question is 60 seconds. If the participant identify without any clues, that is within the first 30 seconds, we will provide full points. A clue will be given after 30th second. If a team couldn't identify within the total of 60 seconds, then the question will be passed and it will be open for all the participants to answer. If the question is open, then the participants can put their answers in their chat box. This is only for the passover questions. Now, is there any doubts for this event, for this round? Participants, any doubts?
மேம் இந்த இண்டிவிஜுவல் ஈவெண்ட்டுக்கு லாட் நம்பர்
லாட் நம்பர் இப்போ நாங்கள் லாட் நம்பர் கூப்பிடுவோம். ஒரு லாட் நம்பருக்கு ஒரு கொஷின் டிஸ்பிளே பண்ணுவோம். அந்த டோட்டலாக 60 செகண்ட்ஸ் உங்களுக்கு டைம். ஃபஸ்ட்டு 30 செகண்ட்ஸ் நாங்கள் க்ளூஸ் கொடுக்க மாட்டோம். அதில் நீங்கள் கரெக்டான ஆன்சர் சொல்லிட்டீங்கன்னா யூ வில் கெட் ஃபுல் பாயிண்ட்ஸ். ஆஃப்டர் 30th செகண்ட் நாங்கள் ஒரு க்ளூ கொடுப்போம். இஃப் அதுக்கப்புறம் நீங்கள் கண்டுபிடிச்சிங்கன்னா கரஸ்பாண்டிங்கான மார்க்ஸ் உங்களுக்கு கிடைக்கும். ஒருவேளை 60 செகண்ட்ஸ் உங்களால் கண்டுபிடிக்க முடியல அப்படின்னா அப்போ வந்து இந்த கொஸ்டின் பாஸ் ஆகும். எப்போ பாஸ் ஆகுதோ அப்போ மட்டும் அந்த கொஸ்டின் வந்து ஓப்பன் ஃபார் ஆல், யார் வேணால் ஆன்சர் பண்ணலாம். அதுக்கு வந்து நீங்கள் சேட் பாக்ஸில் போடணும். பாஸ் ஆச்சுன்னா மட்டும், இல்லைனா இண்டிவிஜுவல் கொஸ்டின் தான். ஓகேங்களா?
ஓகே மேம்.
Okay. Let's go with lot number 8. Please unmute. Video on பண்ணுங்க. The participants are requested to on your video. Lot number 8 மட்டும் unmute பண்ணிக்கோங்க.
Yes ma'am.
Your time starts now. Name the scientist.
Rutherford.
Come again?
Rutherford.
No. Try again. This scientist developed a number of fundamental results in quantum theory. Equation which is named after him provides way to calculate the wave function of a system.
Schrödinger.
Yes. He's Erwin Schrödinger. The next participant, let's go with lot number 27. Lot number 27, your time starts now.
Albert Einstein.
No.
Tesla.
Yes, you're right. He's Nicholas Tesla. Next, we'll go with lot number 28. Lot number 28.
Yes, ma'am.
Unmute your.
Is it visible, ma'am?
Yes, yes, yes.
Okay, okay. Mary Curie, ma'am.
No.
Ma'am. Mary Curie, yeah. Okay.
The scientist gave the theorem which explains the connection between symmetry and conservation laws, which serves as an important aspect in mathematical physics. The scientist gave the theorem which explains the connection between symmetry and the conservation laws, which serve as an important aspect in mathematical physics. This question is a pass now. Anybody can answer?
Mary Curie, ma'am.
No, no. Okay. Lot number 48, it's right. Lot number 48, you're right. Pass. It's Amy Noida. Next year, 27, 28, 49. Let's go with lot number 46. Lot number 46. Your time starts now. Lot number 46. வீடியோ ஆன் பண்ணுங்க. அன்மியூட் பண்ணிக்கோங்க. அன்மியூட் பண்ணிக்கோங்க. She received Nobel Prize for proposing the nuclear shell model of atomic nucleus. She is the second woman to win a Nobel Prize in physics after Marie Curie. The time's up. This question is a pass now. Participants can tell your answer in the chat box.
Ma'am, where we grew up at Mayor?
Yes, you're right, but we asked to give your answers in the chat box. யாஷிகா சொன்னாங்க பட் அவங்க சொன்னாங்க டைப் பண்ணல. Shall we award them? மைக் ஆன் பண்ணி ஆன்சர் சொல்லிடுங்க. ஓகே, ஃபர்ஸ்ட் வார்னிங் இது. பட் யாஷிகா she give a correct answer. இந்த வாட்டி உங்களுக்கு அவார்ட் பண்றோம். பட் நெக்ஸ்ட் டைம்ல இருந்து பாஸ் கொஸ்டின்ஸ்க்கு டெக்ஸ்ட் பாக்ஸ்ல மட்டும் தான் ஆன்சர் பண்ணணும். டெக்ஸ்ட் பாக்ஸ்ல யார் ஃபர்ஸ்ட் கரெக்ட் ஆன்சர் கொடுக்குறீங்களோ அவங்களுக்கு தான் பாயிண்ட்ஸ் போகும்.
Okay, ma'am.
Okay. Yashika, your lot number is 64, right?
Yes, ma'am.
Okay. Now let's go with lot number 49. Lot number 49. Unmute your device.
Yes, ma'am.
Your time starts now. Videos on பண்ணுங்க. This physicist is responsible for the discovery of element protactinium and nuclear fission. The physicist is responsible for the discovery of the element protactinium and nuclear fission. Your time's up. Now the question is open for all. Kindly give your answers only in the chat box. Participants can give your answer in the chat box within 10 seconds. Okay, no points for any participant. Next question. Okay, lot number 48. Lot number 48.
Yes, ma'am.
Okay, this is your turn. Your time starts now. His greatest achievements were the development of statistical mechanics, and the statistical explanation of the second law of thermodynamics. There is a his greatest achievements were the development of statistical mechanics and the statistical explanation of the second law of thermodynamics.
சீக்கிரம்டா.
Fermi.
No, the time is over.
Ma'am, Gibbs.
No, sorry. The question is open for all. Kindly put your answers in the chat box within 10 seconds. We'll go for next question. Lot number 64.
Yes, ma'am.
Your time starts now.
Ma'am? Ma'am?
Kindly wait, Dinagaran. Just a minute. This physicist is responsible for the discovery and the direction of X-rays. Time's up. The question is open for all. Kindly put your answers only in the chat box within 10 seconds. Okay.
Ma'am, kindly check the chat box, ma'am.
Lot number 8. Lot number 8 have give the correct answer first. Next, lot number 49. Sorry for the inconvenience. This question is open for all. Anyone can answer, but you have to put your answer in the chat box. This question is open for all. This is the final question for this round. Kindly put your answers only in the chat box. The first correct answer will get the points. Yashika have given the correct answer. Yashika, your lot number, please.
Yes. 64, ma'am.
64. Lot number 64. It's the correct answer. Now we will move on to the second round. The second round is a challenge to your skill. It comprises of problem solving questions. This is an open round. The first correct answer will get the ultimate points. Maximum duration for this round is 2 minutes. This round is fully open question. Anybody can answer. Put your answer in the chat box. Your maximum time is 2 minutes for each question. Any doubts? Participants?
No, ma'am.
Okay, let's go. The first question, and your time starts now. Time is going to end, and the answer for the question is option B. The first correct answer, Adi Abhinesh.
மேம்
அஜித் குமார், நீங்க ஏ அண்ட் பி ரெண்டுமே போட்டிருக்கீங்க.
இல்ல
ஸோ
பை த மிஸ்டேக் மேம் டைப் பண்றப்ப மிஸ்டேக் ஆயிடுச்சு மேம்.
பட் இட்ஸ் நாட் அவர் ஃபால்ட் இல்லையா? நீங்க ஏபி ரெண்டுமே இருக்கு, இங்க ஏபி ஆப்ஷன்ல இருக்கிறதுனால எங்களால அவார்ட் பண்ண முடியாது.
மேம் மிஸ்டேக்ன்றனால தானே, இல்லைன்னா நாங்க ஏன் சொல்ல போறோம்? உடனே நாங்க கீழே பீன் மெசேஜ் பண்ணியிருக்கோம் பாருங்க மேம்.
பீன் செகண்டா திரும்பவும் பண்ணியிருக்கோம் மேடம்.
உடனே அட் டைம்ல பண்ணியிருக்கோம்.
ஏன் மிஸ்டேக் ஆனிச்சுன்னு திரும்பியும் லாட் நம்பரோட பீன் போட்டு அனுப்பியிருக்கோம் மேடம். ஆதிக்கு கீழேயே.
ஜட்ஜஸ் என்ன சொல்றாங்க நாங்க கேட்டு சொல்றோம்.
ஓகே
மேடம், தேங்க்யூ.
இப்போ இங்க என்ன சொல்றது? Okay. We'll move on to the next question. Last 20 seconds. And the correct answer is 12 Kelvin. We move on to the next question. And the time starts now. Option is given as wrong. The correct answer is option D. So we'll move on to the next question. And your time starts now. The time's up. Next question. Time's up. Next, go for the next question. Please wait. This is your final question. This is the final question for this round. The answer is
What is
1 second. Sorry for the inconvenience. Now let's move to the round 3. This round 3 is
மேம் ரவுண்ட் 2ல ஆன்சர் சொல்லவே இல்லை மேம் லாஸ்ட் கொஸ்டினுக்கு.
last question to display பண்ணோமே. Option A is the right answer.
ஓகே மேம்.
Round 3, this is a boost round. Participants always believe, expect the unexpected. This round enables the participants who are chasing the race can score higher than the participants who are leading the race. Also, the participants who are leading, remember you have got yet another chance to do wonders. This is a rapid fire round. Participants should choose a field of their interest. Questions will be asked and the participants can answer as many number of questions as they wish, but within 2 minutes. ஓகேவா? இப்போ நாங்கள் சில ஃபீல்ட்ஸ் டிஸ்பிளே பண்ணுவோம். அந்த ஃபீல்ட்ஸில் நாங்கள் எந்த லாட் நம்பர் கூப்பிட்றோமோ அவங்க ஏதாவது ஒரு எந்த ஃபீல்டு வேணாலும் நீங்கள் சூஸ் பண்ணலாம். அதில் 2 மினிட்ஸ்க்கு உங்களால் எத்தனை கொஷின்ஸ் ஆன்சர் பண்ண முடியுமோ ஆன்சர் பண்ணலாம். 1-on-1 ரவுண்ட், ஓப்பன் ரவுண்ட் கிடையாது. இண்டிவிஜுவலாக ஒரு லாட் நம்பராக நாங்கள் கூப்பிடுவோம். நீங்கள் உங்களுக்கு எந்த ஃபீல்டு கம்ஃபர்டபுளோ அந்த ஃபீல்டு நீங்கள் சூஸ் பண்ணலாம். ஒன்ஸ் இஃப் field is chosen, then it is not available for another participant. Lot number 8. Before going, lot number 8, please wait 1 second. Other participants, do you have any doubts? இதுதான் ஃபீல்ட்ஸ். இப்போ வந்து நாங்கள் ஒரு லாட் நம்பராக கூப்பிடுவோம். நீங்கள் வர போகிறீங்க, ஏதாவது ஒரு ஃபீல்ட் சூஸ் பண்ண போகிறீங்க. அந்த ஃபீல்டில் அந்த ஃபீல்ட் ரிலேட்டடான கொஷின்ஸ் மட்டும் கேட்போம். ரேபிட் ஃபயர் 2 மினிட்ஸில் நீங்கள் எத்தனை கொஷின்ஸ் வேணாலும் ஆன்சர் பண்ணலாம். ஒரு ஸ்லைடில் ஒரு கொஷின் டிஸ்பிளே ஆகும். உங்களுக்கு ஒரு வேளை அந்த கொஷின் நீங்கள் ஸ்கிப் பண்ணணும்னு நினச்சிங்கன்னா யூ கேன் சே ஸ்கிப்.
லாட் நம்பர் 8 எலக்ட்ரோமேக்னட்டிசம்.
ஓகே, electromagnetism. Lot number 8, electromagnetism. Lot number 8, your time starts. Sorry, lot number 8, video on பண்ணுங்க. Unmute பண்ணிக்கோங்க. Lot number 8. And your time starts now. ஆன்சர் பண்றதுனா ஆன்சர் பண்ணலாம், இல்ல ஸ்கிப் பண்ணனும்னா ஸ்கிப்னு சொல்லலாம்.
Ma'am, option 3, ma'am.
No.
Option C, ma'am.
Okay, next.
Option 4, ma'am.
Next. You have 50 more minutes. 50 more seconds.
Option 3, ma'am.
Next. Skip பண்ணனும்னா skip பண்ணலாம்.
Skip பண்ணிக்கிறோம், ma'am. Skip பண்ணிக்கிறோம், ma'am.
Skip. Last 15 seconds.
Always option A, ma'am.
Okay, next.
Option 1, ma'am.
Okay, time's up. Next slot number 27. Lot
Nobel Prize.
Okay, videos on பண்ணிக்கோங்க. Okay, Nobel Prize, lot number 27, Nobel Prize. And your time starts now. Skip பண்ணனும்னா skip பண்ணிக்கலாம் நீங்க.
Mary Curie.
Next. டைம் போயிட்டு இருக்கு. ஸ்கிப் பண்ணனும்னா ஸ்கிப் பண்ணிக்கலாம்.
Henry Becquerel.
Next.
Carol David Anderson.
Next. Forty more seconds.
Wave particle duality.
Next.
Cooper.
Last 10 seconds.
BCS theory.
Next. Oops. Your time's up.
Okay.
Lot number 28. Lot
Hello?
number 20.
Yes, ma'am.
Videos on பண்ணிக்கோங்க. உங்களுக்கு எந்த ஃபீல்ட் வேணும்?
Electronics, ma'am.
Electronics. Lot number 28, electronics. And your time starts now.
Ma'am, next question, ma'am.
Next question. Next
Yes,
question.
ma'am.
Two, ma'am.
Next.
Next.
Next question.
Next question.
Three.
Next.
Next, ma'am.
Next, ma'am. Next, ma'am.
A, ma'am.
Next. Next.
D.
Next. Last 20 seconds.
C, C.
Next.
Ma'am,
Sorry.
screen is not visible, ma'am.
Sorry. We'll give time. Wait.
Next one, ma'am.
Wait. விட்ட டைமிங்ல இருந்து இப்போ ஸ்டார்ட் ஆகுது. ஓகே, டோன்ட் பேனிக். கண்டினியூ.
B.
Next. Time's up. Next lot number 46. Lot number 46.
Invention and discoveries.
Lot number 46, inventions and discoveries. And your time starts now.
Galileo.
Next question வந்துருச்சு பாருங்க.
Charles.
Okay.
Charles Fumco.
Next question.
Next, ma'am.
Next.
Ma'am.
Next.
Paul Willett.
Next.
Robert Bunsen.
Next. Time's up. The next contest. Okay. The next participant, lot number 48. Lot number 48.
Yes, ma'am.
Videos on பண்ணிக்கோங்க. என்ன field?
Thermodynamics.
Thermodynamics. 48. And your time starts now.
Zero. Option A. Option A 0.
Next. Next. வெளில இந்த நாய்ஸ் வருது.
Okay, ma'am. Ice. Option A. Ice. Option A.
Next. அன்மியூட் பண்ணுங்க.
First லாம்.
நெக்ஸ்ட். ஃபுல்லா அன்மியூட் பண்ணியே வைங்க. மைக் அன்மியூட் பண்ணி வைங்க. Last 45 seconds.
Option C. Option C 60%.
Next.
Isotherms. Option E. Isotherms.
Next. Last 20 seconds. Participants should not off your mic.
None of this. Option D. Option D.
Next.
Second option.
Time's up. Okay. Next, lot number 49. Lot number 49. Lot number 49.
Yes, ma'am.
Field. Measurements. Lot number 49. Measurements. Your time starts now.
Vector, ma'am.
Next question. Unmute பண்ணுங்க.
29.5. 29.5, ma'am.
Okay, next question.
kilogram.
Next.
Next, ma'am. Next question.
Next.
Next question. Next, ma'am.
Next.
Dimension of resistance and capacitance.
Last 30 seconds.
L power minus 1. L power minus 1. L power minus 1. T power minus 2.
Next.
Watts per square meter.
Watts per square meter.
நெக்ஸ்ட் வெள்ளத்துல வர அன்னெசரி நாய்ஸ் அவாய்ட் பண்ணுங்க.
Okay, ma'am. Yes, ma'am. True.
நெக்ஸ்ட் டைம்ஸ் அப்.
Okay, ma'am.
Lot number 64. Lot number 64.
Yes, ma'am.
உங்களோட theme.
Ma'am, already choose பண்ண field choose பண்ணலாமா ma'am?
No, no.
பேலன்ஸ் என்ன மேம் இருக்கு?
Optics, theorems and laws, classical mechanics, nuclear physics.
என்ன choose பண்ணலாம்? மெக்கானிக்ஸா ஆப்டிக்ஸா? Optics. Optics, ma'am.
Optics. Okay. Lot number 64, optics. And your time starts now.
The colors in the rainbow are formed by dash phenomenon. Refraction, reflection. Ma'am, second option.
Next.
The rear mirror of the vehicle seen produced. First option, move and dynamically. Ma'am, next question.
Next.
What is the velocity of light in a diamond? Velocity of light in a diamond refractive index. Ma'am, next question.
Next.
Five by two. Ma'am, previous question காட்டுங்க.
Previous question.
Ma'am, அந்த problem மாதிரி. Ma'am.
Last 40 seconds.
Ma'am, last option.
Okay, next.
Ma'am, second option, ma'am.
Okay, next.
Which of the following cannot be polarized? X-ray cannot be polarized. Next question, ma'am.
Next.
Light cannot be polarized. So the following does not change.
Last 15 seconds.
Wavelength, velocity. Wavelength, ma'am. Last option.
Next.
Ma'am, previous question. Next question, ma'am. Next question.
Time's up.
Okay, ma'am. Thank you.
We congratulate all the participants for your active participation. The results of all the rounds will be shortlisted and be announced tomorrow. Thank you. The participants can leave for the next event.
participant and they have to explain their ideas without exceeding the time limit. I repeat, we will display the PPT submitted by the participants and they have to explain their ideas without exceeding the time limit. Now I start with the lot 1. Lot 1, Afshar Miran from Cookie Rockers. Are you ready? Ready to present?
Yes, I am ready to present.
Can I start the timer?
Okay, let's go.
Okay, your time starts now.
Good evening to all. I am Afsar CJ, lot number 8. I am going to present the topic of quantum teleportation. These are the topics to be covered in the presentation. Next slide. Hello.
Yeah.
Next. These are the topics to be covered in the presentation. Next. The introduction part, I am going to discuss about the quantum teleportation. Quantum teleportation is nothing but a transferring information between the particles. It is based on the principle of quantum mechanism. Next one. It is mainly based on the as it is a process that what I called the process teleporting an object from one place to another place, like entanglement. It's the basic of the principle of entanglement. Next. This is a quantum entanglement process. Quantum entanglement is an entanglement teleporting an object between 2 points. Quantum entanglement particle of photon separated by a large distance in act as an opposite direction. Opposite reaction is like that. Next slide. History of quantum teleportation. Now we're going to see history of quantum teleportation. The term was first introduced by an Austrian physicist, Erwin Schrödinger, in 1935. Next. The Bob and Alice want to teleport her qubit. Like a qubit is nothing but a quantum bit. She used a teleportation algorithm to teleport her qubit to his qubit. Now, an teleportation essential tool and a field of an information science. Next one, applications.
Time up.
Okay, thank you.
Thank you, Ashwin. Now lot 2 number lot number 2, Miss Bhavani from Stranger Stars. Are you ready? Miss Bhavani from Strange Stars, are you ready to present? Miss Bhavani, am I audible to everyone? Mike.
Yes.
Yeah, yes, ma'am.
So now I call upon Mr. Gokul from Sonic Stars. Are you ready?
Yes, ma'am. Am I audible?
Yeah, you are audible.
Okay, ma'am.
I will present.
Ma'am?
Yeah, I will
start?
present.
Ma'am, I want to tell one thing.
Yeah.
You don't slide my PPT. I just tell brief about the quantum teleportation.
Why, Pa? Why? What's the reason?
Ma'am, within the time limit, the 22 slides is not possible. So that's why I tell briefly about the quantum teleportation.
Okay, then your wish, you can proceed. I will start the timer.
Yes, ma'am. Okay.
Now your time starts now.
Hello, good afternoon to one and all. Let me talk about brief explanation about quantum teleportation. The idea of teleportation has been around in fiction and mythology over 1,000 years. People have been inventing new ways to travel faster from one point to another. Here, quantum plays a vital role. A technique which combines the properties of telecommunication and transportation to achieve a system for traveling is called teleportation. It involves the transportation of information rather than the transformation of matter, and also involves dematerialize at one place and rematerialize at another place. Here, no cloning theorem is also employed because quantum teleportation of original state was destroyed here. Quantum teleportation is achieved using quantum entanglement. The entanglement can exist between different systems which have the same wave function if and only if superposition can exist in each of them simultaneously. It violates the Bell's inequality. For that, our scientist Clausier, Alan Aspect, and Zeilinger got Nobel Prize in 2022. But this concept did not violate the theory of relativity, because communication transfer from one entangled state to another entangled state through the physical phenomena, it not breach the velocity of light. So the main application of quantum teleportation is quantum computing and quantum cryptography. Now, scientists successfully teleporting a quantum particle over 870 miles. Here, some of the advantages are higher transmission rate, secure data transmission, and no signal loss are this advantage, and no accident is happened in between the transmission. So we are away from being able to teleport and entangle bulky object, but we physicists are sure to continue to improve upon the ideas of quantum teleportation.
Time up, Gokul. Thank you for your presentation. Now I call upon yes, Sandhya from Physics Panthers. Are you ready?
Yes, ma'am. Am I audible?
Yes, pa. Please wait. I will open your log. Is it visible to you, ma?
Yes, ma'am.
Are you ready?
Yes, ma'am.
You can present now.
Yes, thank you. Good afternoon to everyone. My presentation is about quantum teleportation, the incredible quest. First, before seeing what is quantum teleportation, I want to tell what is the outline. So we have to discuss about Einstein's theory and Copenhagen interpretation, which tells about this. Einstein theory tells about the reality was knowable and probabilities could not completely define reality. And Copenhagen interpretation tells value only be known once it measured. After that, Einstein disagrees with the Copenhagen interpretation, which means he tells that nothing can travel faster than the light, according to his theory of relativity. That's why he invalidated the Copenhagen theory. Next slide, please. So after that, EPR paradox came. EPR paradox is nothing but the group of scientists, they told about the hidden variables between the two quantum particles, and this EPR paradox, based on this paradox only, Bell's equality equation came, and violating this Bell's inequality, the researchers have identified that quantum particles, quantum entanglement, and quantum teleportation concept. This quantum teleportation is nothing but a transferring of quantum information, which is a qubit from a sender to one location to a receiver in some distance away. And this quantum teleportation has a lot of advantages, which also involves quantum computing, quantum chip, quantum supremacy in everything. And Einstein called this quantum entanglement as spooky relation at a distance. And after all completing that, violating this Bell's inequality, after the successive Bell's inequality experiments, these researchers got Nobel Prize at quantum based on the quantum entanglement. So this was the concept of quantum teleportation. Thank you.
Thank you. Thank you, Sandhya, for your nice presentation.
Thank you.
Next, I call upon Chandru from Mighty Meteors. Are you ready?
Yes, ma'am. Am I audible?
Yes, you are audible.
Good evening to all.
Wait. Your time starts now.
Good evening to all. Today see about quantum teleportation. Next slide, ma'am. Yeah. Next slide, ma'am. Introduction. Yeah. Introduction. More than 5 years ago, people have invented a new way to travel to pass from one point to another. Each these forms transportation can be same one. Teleportation can be classified into 2 types: classical teleportation and quantum teleportation. Classical teleportation is exactly a replica of the source object is obtained in the destination, whereas quantum teleportation in an exact copy of the source objects is obtained at the destination and the source object is destroyed. Quantum teleportation. Next slide. Next slide. Quantum teleportation is the making of an object or person disintegrate or one place to a perfect replica appears somewhere else. The replica is not necessarily from the actual material of the original, but a paragraphs were from atoms of the same kinds arranged in an exactly same pattern as the original. A photon experiment has proven a technology. In 1988, the physics of the California Institute of Technology, along with the 2 European groups, turned the ideas into the reality of successfully teleporting a photon. The Catchlight group was able to read an atomic structure of a photon. Photon sends this information across 1 meter of a coaxial cable to create a replica of the photon. Human teleportation. The technology is explained. The human telephone is called a biodigital cloning. In biodigital cloning was the original mind of body of the tele-traveler would be no longer exist. Instead of their atomic structure would be recreated in another location. So the travelers would still exist.
Time appa.
Thank you.
Next, I call upon Harish Narayanan. Are you ready?
Yes, ma'am.
One second, Harish. Hello. Jayashree?
Okay.
Yes. Who is Sitesh? Is he in this link or he is in the second link?
Siteshwari, are you in this link?
Yes, ma'am. Sitesh, your name is not in our. In which list, Jayashree, check him? She or her? She or him?
She, ma'am. Sorry, ma'am.
Okay. Your name is Siteshwari.
Siteshwari, ma'am.
Siteshwari.
Yes, ma'am.
Okay. Okay, da. Okay. You can start, Jayashree.
Okay.
Hello, Jayashree.
Yes. Hello.
Are you batch 2, not in the batch 1? Hello.
Hello, Akka, am I audible, Akka?
Jayashree.
Yes,
check.
Akka.
Hello.
Yes, Akka.
Check whether Siteshri is in this link or in the second link?
Siteshwari should be in the second
Hello?
link. She's not. She's in the batch 2.
So ask her to leave this link and
Okay. Siteshwari, you kindly leave this link.
Okay, next participant.
Next participant.
Harish, lot number 6.
Yes, ma'am.
You can start. Wait.
Okay, ma'am.
Please wait for 5 minutes. We are preparing your PPT.
Okay, ma'am.
Six. Number 6. Is it visible for Harish?
Yes, ma'am. Start, ma'am.
Yeah.
Ma'am.
Wait for 2 minutes.
Okay, ma'am.
Give us time. Sixth. Two. Harish,
Yes, ma'am.
you can present now.
Okay, ma'am. Today I come with an interesting topic, quantum teleportation. So what is quantum teleportation? It is a technique for transferring quantum information from a sender at one location to a receiver at some distance away. If you look into the history, so many scientists contributed to quantum mechanics, but I here like to name few. Niels Bohr, Max Planck, Oppenheimer, who are all led a basic fundamental platform to the quantum teleportation. But in 1997, Popescu and Zeilinger proposed the area of quantum teleportation. In 2014, scientists transferred data by quantum teleportation over a distance of 10 feet with a 0% error rate. In normal computers consist of billions of transistors and store the information in form of bits. But quantum computers encode information in form of qubits.
Okay.
A pair of qubits is known as EPR pair. The phenomenon behind the quantum teleportation is quantum entanglement. It is the aspect of one particle of an entangled pair depend upon aspects of other particles, no matter how far apart they, what lies between them. The protocol for quantum teleportation is described by the Bell state. A Bell state is generated with one qubit sent to location A and the other sent to location B. In 2002, Alan Aspect and John Klausner and Anton Reininger have discovered that the entangled particles behave like a single unit even when they separate far away. This 2022 Nobel Prize highlights an important milestone in our understanding of quantum mechanics. Thank you, ma'am.
Thank you for the presentation. So next comes lot number 7, Kanagavalli. It'll put a timer.
Yes, ma'am, I'm here. Am I audible?
Okay. Yes, you are audible. That's the presentation.
Yeah, thank you.
Hello? Hello? Kanagavalli?
Yes, ma'am.
Are you there? Shall we start?
Yes, ma'am.
Okay.
Yeah, sure.
Okay, da. Which presentation? 7th. Restart. Kanagavalli? Kanagavalli?
Yeah.
Your voice is not clear.
Yes, ma'am.
Hello? Your voice is not clear.
Yes, ma'am.
Yeah.
Ma'am, yeah, okay, right?
Okay, you can start.
Yeah, thank you. So, a very good afternoon to all the present here. So, I'm going to talk about quantum teleportation here. So, teleportation is not a new thing to us. We have heard about teleportation, but quantum teleportation is something different. And even teleportation is something remaining like a myth or a fiction-like thing. But quantum teleportation in recent years, we have said it to be we have included in our real life too. We have many real life applications. So let's see what quantum teleportation is. So the transfer of information, data from one location to another location without any signals in between. So that's what called as quantum teleportation is. Ma'am, next slide, please. And I'm also going to the next slide. And I'm also going to discuss about no cloning theorem and no deleting theorem, which is basic in quantum. And the next slide, please. So, what are the applications of real life in a quantum? What are the applications of quantum teleportation in real life? Because any technology that have to be implemented in real life, that will be considered to be useful, right? And coming to quantum, it is completely new, but there are many applications that quantum teleportation gives. Quantum network. First of all, who succeeded in quantum network? China succeeded and Canada succeeded. So I'm going to talk about it in next part. And next slide, please. And also, I'm going to talk about various applications of quantum thing.
Disconnected.
Like there are more applications. Like my next slide, please. Secure communication and quantum computing, and we are using quantum computers in real life, which is extremely super cool compared to classical computers. And I'm going to talk about the transportation between light and matter, and what are the experimental status of quantum in real life. Thank you, ma'am.
Okay. Okay, thank you for the presentation. Next comes lot number 8, Kamalini. Kamalini, are you
Yes,
there?
ma'am.
Okay. Wait.
Do I am audible?
Yeah, you are audible. That's the PDF. Okay, you can start your presentation. Audible now? Wait. Is it visible now? Kamalini,
Yeah, yes, ma'am. Yeah,
is it
it's
visible now?
visible now.
Okay. Okay, you can start your presentation. Your time starts now.
A very good afternoon to everyone present here. I'm Kamalini, lot number 8 from Lunar Rover team. Ma'am, it is not visible, ma'am.
Is it not visible?
Excuse me.
There is no problem with our connection. Check your connection, please. Please check your connection.
Can I? Yeah, it's okay, ma'am. So next slide, please, ma'am.
One second.
Which means transferring of ma'am time is running.
Yeah, we will give you extra time. Oh. You can. Kamalini?
Oh.
Hello?
Excuse
Kamalini?
ma'am.
What happened? Are you there? Hello? Okay, Kamalini, you can present at last.
Last. Yes, ma'am.
Okay. Next comes the lot number 9, Hari Prasad.
Good evening, ma'am. May I audible?
Yeah, you are audible. Wait for a minute. 9.
Yeah, sure.
Okay, you can start. Hello?
Yeah.
Hello.
Good evening,
Okay.
everyone. This is Hari Prasad from National College Trichy, and my presentation topic is quantum teleportation and incredible quests. Let us have an outline of what I am going to discuss here. Quantum teleportation is based on, next slide, ma'am, based on hypothesis named EPR paradox by Einstein and his colleagues in 1935, which would seem to be violating the limit of speed of light. Before going into quantum teleportation, we must have a prerequisite knowledge of these concepts like quantum entanglements, qubits, no cloning theorem, etc. Quantum teleportation is a technique for transferring quantum information from a sender at one location to a receiver at some location away. And next slide, ma'am. The slide is protocol slide. Next slide, protocol. Yeah. To transfer a quantum bit, Alice and Bob must use a third party to send them an entangled qubit pair. Alice performs some operations on her qubit and send information to classical communication channel, and Bob then performs some operation in his head to receive the resulted qubit data. The various states of quantum teleportation of signal is shown in the next slide. And next slide. Okay, on 4th October 2022, it was awarded Nobel Prize for quantum teleportation to these people. The contribution of these people is explained in this slide. On teleportation, next slide. And teleportation concept, which seem to be myth, is explained in various ancient texts as shown. Which is next slide. Yeah. And next slide. Quantum teleportation in recent days. Actually, in recent days, University of Queensland and National Institute of Standards and Technology is highly focused in quantum internet. And the challenges in using quantum teleportation is there is no limit for input data, and data can be viewed by third person apart from sender and receiver. There are some other challenges yet to be discussed.
Okay, your time is up. Thanks
Thank
for
you.
your presentation. Next comes lot number 10, Niveta. Niveta, are you there? Niveta, lot number 10. Lot number 10. Okay, next lot number 11. Parivardhan.
Yes,
You are
Parivardhana.
Niveta.
Okay, Parivardhana. Okay, wait for a minute.
Lot number 11, Parivartana, ma'am.
Okay, wait. Okay, is it visible?
Yes, ma'am.
Okay, now you can start your presentation.
Good afternoon to one and all gathered here. I am V. Parivartana from National College from the team Garnet staff. I am going to present on the topic quantum teleportation, the incredible quest. Before going to know about quantum teleportation, we must know what is teleportation. Do you know what is teleportation? Teleportation is a hypothetical transfer of matter of energy from one point to another without transferring the physical space between them. In much simpler words, teleportation means to disappear and then reappear at a different place. If we are in a phase of a freezing cold, probably we could teleport ourselves inside a place which is much warmer. Next slide, ma'am. Now we are going to see about quantum teleportation. This process is based on the principle of quantum entanglement, which means a phenomenon in which two distinct particles in the quantum state remain constant communication with one another. By taking advantages of this phenomenon, information can be transferred faster than the speed of light. Next slide, ma'am. Yearly article. Recently, the Nobel Prize for Physics 2022 was awarded for Alan Aspect, Jonas Glaser, and Anton Zeilinger for the experiment with entangled protons, establishing the violation of Bell inequalities and pioneering quantum information science. Not only these three scientists, many of the scientists are involved in the growth of quantum teleportation. Next slide, ma'am. Next slide. Next. And also, I included some of the scientists who are considered as the pioneer of quantum teleportation. And also, I included some interesting latest updates in quantum teleportation. In March 2021, Chinese researchers successfully completed a different kind of quantum teleportation, experimenting 5 quantum teleportation experiments using 5 quantum photons at location 870 miles apart, and the following 4 points of interesting facts. Next slide, ma'am. Next one. I completed my presentation with a valuable quote of Mary Curie. Nothing is to be feared, it's only to be understood. Thank you.
Thank you for the presentation. Next comes lot number 12, Vijay Kumar.
Yes, ready, ma'am.
Okay.
Can I start, ma'am?
Wait. Is it visible?
Yeah, it's visible.
Yeah. Okay, now you can start.
Good afternoon to all. Today I'm going to present a small topic, quantum teleportation. Next slide, ma'am. Ma'am, some text is there. Yeah. So I'm going to start with just a small question. We all know that matter cannot be teleported directly. Then what is the thing that is teleported? So it is the information which is teleported from one place to another. Next slide, ma'am. We all know that electrons, atoms, and humans, all these are matters, and these matters cannot be, which are described as set of classical bits. These cannot be directly teleported in the form of bits, that is, we all know in the binary form 0, 1, 0, 1, etc. Next one, ma'am. So what is teleportation? In very simple words, teleportation is to disappear at a point and reappear at another point. But here we are going to deal with the quantum teleportation. In quantum teleportation, we must know about the quantum entanglement and qubit. Qubit, which is the basic unit of information. Previous slide itself. Qubit, which is the basic unit of information, can be transmitted from one place to another instead of the matter, which is directly transmitted from one place to another. So next one. So we need to know about the need for teleportation. Teleportation, the word itself is a combination of 2 words, the telecommunication plus transportation, which gives teleportation. Next one. So these all started in 1993. The idea began from Charles Bennett and in his laboratory with his colleagues. Next slide. So initially they failed. It is because of they failed to prove the uncertainty, Heisenberg's uncertainty principle. Next one, ma'am. And these 3 people won the Nobel Prize to improving the violation of Bell's inequality and experimentally they proved the quantum entanglement for 2 quantum states at a far distance.
Okay,
This
thank
is
you for
just
the
a first step.
presentation.
Vijay Kumar, your time is up. So next comes lot number 13, Shiva Priyadarshini. Are you ready?
Yes, ma'am.
Okay, wait for a minute.
Yes. Ma'am, could you please start with the third slide?
Okay, sure. Is it visible?
Yes, ma'am.
This one?
Yes, ma'am.
Okay, you can start.
Yes, ma'am. Okay, good afternoon, everyone. And I'm going to take a brief about a topic, quantum teleportation, the incredible quest. So, scientists have proved quantum teleportation is possible, but not in our real world, but in the quantum world. So, quantum teleportation is the process of sending an information from one object to other object, which is far away from each other. So, at the distance of billions of light years. So quantum teleportation have a major applications. So it is useful in the field of quantum computing, which is used in medical purposes and also in science purposes. So quantum teleportation is based on the phenomena called quantum entanglement. So quantum entanglement is nothing but if you have two particles.
ஐயோ
So,
சாமி 2 நிமிஷம் தான் இருக்கீங்க இப்ப
Anyone is interrupting? Hello, can you mute the mic?
நான் என்ன நினைச்சேன் ஸ்லைடு நம்ம மாத்தலாம்னு
Hello,
நினைச்சது அவங்க
Vijay Kumar.
மாத்தலாங்க
Vijay Kumar, please mute your mic.
சரி இது
Vijay
பண்ணாமையே
Kumar.
இருக்கலாம்
Vijay Kumar.
இது ஓகே சரி அப்படி சொல்லி சமாதானப்பட்டுக்க வேண்டியதான் பாத்துக்கலாம் அப்ப இது பார்த்தானே நெஞ்சு விட்டு செத்துருப்போம்
Okay, sorry. Shiva Priyadarshini.
Shall I start again, ma'am?
Okay, whether you want to start from the beginning?
Okay, ma'am. From quantum entanglement, ma'am.
Wait for a minute. Is the slide is visible?
Yes, ma'am.
Okay, you can.
Yes.
Start.
Okay, ma'am. So, good afternoon, everyone. And my topic, and I'm going to cover the topic quantum teleportation, the incredible quest. So, scientists have proved that quantum teleportation is possible, but not in our real world, but in the quantum world. So, quantum teleportation has major applications, especially in quantum computing. So, it is also an application of medicine in the field of medicine and science. So, quantum teleportation is based on the phenomena quantum entanglement. So, quantum entanglement is nothing but if consider a particle source. So, if you separate the particles from that source and separating them from the far distance, so then that two particles can communicate with each other immediately if we change the one particle with the other. Okay, so this is quantum entanglement. But Einstein did not accept this quantum entanglement, and he proposed an EPR theory. From that theory, he did with the other two scientists, he did a thought experiment. From that experiment, he told that quantum mechanics was incomplete, and also he told this quantum entanglement as a spooky action at a distance. Okay, he told that this quantum entanglement is violating locality and realism. So locality is nothing but nothing can travel greater than a speed of time, light. Realism is things have definite value that we measure or not. So then comes Bell. Here comes Bell. Bell told formulated an equation. In that equation, he told that anything which ranges between the value of his equation is not violating the classical mechanics. Other than it violates classical mechanics. So there are three scientists who got the Nobel Prize for violating the Bell's inequality. So the three scientists violate Bell's inequality and prove that quantum teleportation is possible. Thank you.
Okay. Thank you for the presentation, Shiva Priyadarshini.
Thank you, ma'am.
Next comes lot number 14, Aishwarya. Aishwarya, are you there? Aishwarya, are you there? Okay. Next comes lot number 2, Bhavani. Bhavani, are you ready, da?
Yes, ma'am.
Okay, wait. Okay, is the slides are visible?
Yes, ma'am.
Okay. You can start your presentation now.
Good evening to all. I am Bhavani. I am going to talk about quantum teleportation, the incredible quest. Outline of the talk, introduction about teleportation, types of teleportation, need for teleportation, quantum teleportation, applications, advantages, and conclusions. Next slide. Introduction. Ever since the wheel was invented more than 5,000 years ago, people have been inventing new ways to travel faster from one point to another, such as chariot, bicycle, automobile, airplane, and rocket, etc. Have been invented the amount of the time we spend getting to our destinations. Sometimes scientists work right now such a method of travel combining properties of telecommunication to achieve system called teleportation. Next. What is teleportation? Teleportation is a process in which scans the object dematerialized and transmitted to another location with the object rematerialized back to original state. Teleportation. Teleportation is a system unique and has been designed to allow communication naturally with the anyone or any one of the group people anywhere in the world. Next. Quantum teleportation. Quantum teleportation is an important means for transmitting quantum information in quantum computing. Researchers are exploring new ways of creating quantum mechanical information between distant objects. Next. There are two types of teleportation, classical teleportation and quantum teleportation. Need for teleportation. For actual teleportation, it is required that integral quantum state or belt state be created, quit bit transferred. Integral impose statistical correlations between otherwise
So
distant
Aishwarya, your time is up. We didn't start the timer at the beginning, so we will end here. Hello, Aishwarya? Aishwarya?
Ma'am, Bhavani.
I think
Sorry,
this is
Bhavani?
Yes,
Bhavani?
ma'am. Yes, ma'am.
Okay. Okay, you can stop here.
Yes, ma'am.
Okay. Lot number 15, Parkavi is there? Lot number 15, Parkavi. Lot number 16, Janani. Lot number 16, Janani. Lot number 17, Nandini. Nandini, lot number 17. Lot number 18, Gayatri. Lot number 18, Gayatri. Okay. Lot number 8, Kamalini.
Yes, ma'am.
Okay. Can you present now?
Yes, ma'am.
Okay. Is the slides are visible now?
Yes, ma'am.
Okay. Okay, we will put the timer here. You can start. Hello? Kamalini?
Ma'am, timer is running or not?
We are doing here. Hello?
Can I start?
You can start, you can start. One second, Kamalini. Stop sharing. Lot number 8, Kamalini, are you there, da?
Yes, ma'am, but screen is not visible.
Wait. Screen is not. Okay, is it visible now? Kamalini? Okay, Kamalini? Lot number 8, Kamalini?
Yes, ma'am, now it's visible.
Okay, you can start now.
A very good afternoon to everyone present here. I am Kamalini, lot number 8 from Luna rover team, going to explain about you quantum teleportation. Next slide. Which means transferring of quantum information without any medium. The information are nothing but photons, atoms, and electrons. What exactly this means? Dematerializing a body from one place and materializing it to another, which is very much clear from the image. Important theory which should be noted is no cloning, no deleting theory. Nothing can be copied, nothing can be destroyed. Next, before that, we need to know about quantum entanglement. As these particles are created from a single particle, it shows a property unique link, which is spooky action. Two particles having opposite spin up and spin down. Both particles have single wave function. It doesn't depend upon the distance. It could be miles and light years, but the effect is opposite spin. If we are talking about the issues faced by a network that is hacking, quantum computers can make the future network hacking proof. Next. 10 minutes. Here from the image, it is very much clear. We are assuming Alice and Bob. Yeah. If we are considering quantum particles, we have to consider the superposition principle. Until the quantum particles are measured, they remain in all their possible states, also known as superposition particle. Wave function collapse and comes to one state. If we measured them individually, the wave function collapse and the teleportation is not possible. Measuring their combined state is Bell measurement. From this, it is very much clear from the image before what it happens and after what it happens.
Lot number 8.
Is possible by the Q.
Lot number 8, your time is up.
Okay, thank you, ma'am.
Thank you for the presentation. Participants are asked to wait for a few minutes. We will announce the results. So wait for 10 minutes. Wait for 10 minutes. We will be back. Thank you all.
for 5 minutes, followed by interaction with the judges. I wish all the best to the all. Sir, can we start the presentation even?
Yes.
Now I call upon S. Sandhya to share her work. Sandhya, are you here? Can you hear
Yes,
me?
sir. Yes, sir. Am I audible, sir?
Yes, ma'am. Shall we start the timer now?
Yes, sir.
Okay, carry on.
So, good afternoon to everyone present here. My presentation is about quantum teleportation, the incredible quest. So, next slide, please.
Video.
The quantum teleportation is nothing but the transferring of quantum information from one location to another without disturbing any, without disturbing any quantum information. And also, after that, quantum entanglement is also the concept which comes under this theory. Before seeing that, we need to know about the heated debate between the Einstein and Niels Bohr about the reality and probability of realism, and they both are disagree with each other. After that, Einstein disagreed with the Copenhagen interpretation because it affects his theory of relativity. Next. So he disagreed with Copenhagen interpretation because he is affected with the relativity theory. Next slide, please. So the pictures reveals that quantum entanglement and spooky action at a distance because Einstein defined this as spooky action at a distance. Here the concept that nothing can be traveled according to the speed of light. So he disagrees and follows this EPR paradox. This EPR paradox is nothing but it tells about the hidden variable which allow them to know what to do when they are detected. And they also speak about the local realism, which is locality and realism. Local realism is nothing but where you can't travel more than the speed of light, and realism they have definite values. So that's why he considered this entanglement and spooky correlation at a distance. So
Sandhya?
after that,
Sandhya, sorry for the inconvenience.
yes, sir.
We are facing some technical glitches. Will you able to share the screen? Share your screen. Your own screen. Do you have the PPT now?
My screen.
Yeah.
Okay, sir.
Can you share your PPT? We are facing some technical glitches. Sorry for that inconvenience. Dear participants are requested to stay ready with the PPT to present their work. And Sandhya will be given full 5 minutes again. Sorry for the inconvenience caused.
Sandhya, are you able to present?
Yes, sir. I am about to present, sir.
Yeah. Please.
Sir, whether my screen is presented? Excuse me, sir.
No more.
Can you try now?
Sir, 1 second, sir. Sir, is now my screen is presented, sir.
Yeah, it's okay. It's coming. Yeah, fine. Yeah, go ahead.
Shall I start my presentation, sir?
Yes, ma, your time starts now.
Good afternoon to everyone present here. My topic is quantum teleportation. The incredible quest. So these are the outline, and the quantum teleportation is nothing but it's a technique for transferring quantum information from a center at one location to receiver at some distance without disturbing any quantum information. And this quantum information is nothing. It's like a qubit, and we need to know other topic, that is entangled particles in quantum entanglement. It's behave like a single unit even when they are separated far away. And this picture tells about the quantum entanglement, spooky action at a distance. Before we know that, we have to know about the heated debate between the Einstein and Niels Bohr about the Copenhagen interpretation, where Niels Bohr disagree with Einstein, and Einstein disagree with Copenhagen because he tells that nothing can travel with the speed of light. And also it affects his theory of relativity. That's why he involved Einstein-Podolsky-Rosen theory. He proposed this theory and he told that quantum mechanics were missing someone. And there are also the hidden variable between the two quantum information of photons. And they also told about the local realism, which is the combination of locality and realism. Locality is nothing but you can't travel more than the speed of light, and realism is things have definite values. So by knowing this polarization and faster than speed of light, Einstein believed it is incompleteness, and he termed this as spooky correlations at a distance. And this quantum entanglement, it's a concept which the particles hold mutually exclusive states. And here the important point is correlation. If we know spin state of one system, we automatically know the spin state of other simultaneously. And it also allows the qubits that are separated at a distance to interact with each other, most importantly without disturbing the quantum information stored within it. And here comes after EPR paradox, the Bell, John Stewart Bell, he devised this Einstein's theory into Bell's inequality. And he proposed that if there are any hidden variables, there will be the measurements, mathematical constraints within that hidden variable. He conducted a lot of series of experiments, and according to CHSH value, the CHSH is nothing but a group of scientists who perform the experiment by implying hidden variables. So they found that maximum value is to be less than or equal to 1. But the thing is, after the researchers, our Nobel Prize winners, they have found that it exceeds 2. Actually, the real value is 2.8. So automatically, this quantum mechanics violated this Bell's equation. So that's why it is called Bell's inequality violation. And it is incompatible with the local realism. And it is described by wave function, because wave function here is when a particle is observed, its wave function collapses and measured quantity takes on a single measured value. Actually, Einstein disagrees with it, but it's a perfect thing. And particles don't have specific values till you measure. Here comes the qubits, which can have either 0 or 1 simultaneously. And this is Bell experiment. This was conducted by our Nobel researcher. The picture here depicts that measured entangled photons multiple times, and using polarization as his measurement, he proved violation of Bell's inequality. And the picture B shows that experiment demonstrated by the Allen expert. He experimented he enclosed the loopholes of closure, and Zallinger demonstrated the important phenomena called quantum teleportation. Here comes our topic also. He demonstrated the concept called quantum teleportation. Here the important point is state changes are instant. Nothing physically moves from one place to another. And he created entangled pair of photons by shining a laser on special crystal and used random numbers to shift the measurements. So this is most important thing, and this is the demonstrated about the quantum teleportation. And these are the advantages of quantum. Here the photon, the photon, quantum state of photon have been traveled to a crystal. Crystal here act as a memory bank This is an record setter because before it was sent it to 6 kilometer teleported. Now it is teleported to 25 kilometers. This complex phenomenon is called quantum teleportation. And this quantum teleportation is also used in a lot of system bank account for this encrypted communication. And most importantly, the development of chip, it is achieving the quantum technology. And if we are achieving quantum supremacy, quantum computing is very faster than the supercomputer because it can have either 50-50 probability which state it will be. That's why it's faster than our supercomputer. So at last I need to end up with like this. We are in the age of humanity where quantum technology is
Sandhya, thank you for your presentation. Your time's up. Now it's time to interact with the judges.
Yes, sir.
Okay, Sandhya.
Yes, sir.
So, what is do you know the Pauli's exclusion principle?
Sir, can you repeat this question, sir?
Pauli's exclusion principle.
Yes, sir. No two electrons can be on the same state, sir. That is Pauli exclusion principle.
It is only for electrons or any other thing?
No, sir. It is for like fermions, sir.
Okay. Okay, fine.
Thank you, sir.
Can we call the next participant?
Next one.
I call upon Geeta Bharati to present her work.
Yes, sir.
Geeta Bharati, you can present your work now.
Yes, sir.
எல்லாரும் participants எல்லாருமே இருக்காங்க. ஓ, ஓகே. क्वेश्चन நம்ம கேட்ட மாதிரி क्वेश्चन சேம் क्वेश्चन கேட்க முடியாது எல்லாரும். பிரசன்ட் பண்றது யாரு? ஷர்மிளா. சந்தியா பிரசன்ட் பண்ணிட்டாங்க. அடுத்து யாரை கூப்பிட்டுருக்கீங்க?
Now it's Geeta Bharati's turn, sir.
Sir, is my screen visible?
Geeta Bharati.
Sir, is my screen visible, sir?
Yeah, order மாறி இருக்கு. No, not yet. Okay. Sir, this is share your slide. There is only this is your slide. Okay. Sir, one more.
Just a minute.
Not sir. நீங்க பண்றீங்களா அவங்க பண்றாங்களா அப்ப? We sharing. Okay. Let's get it.
Geeta Bharati, please share your screen.
Yes, sir. I'm trying. Just a network issue. Just a minute.
Okay, you will be given a chance later, which means you will be given chance. But shall we move to the next participant, Geeta Bharati? Is it okay for you?
Okay, sir. So now it is. I think so.
Okay, you just bootstrap your internet connection and other things. We'll move on to next participant. You will be allowed to present your screen once. Okay, it seems you have presented your screen. You can start your presentation now.
Yes, sir. Sir, it is visible now?
Yeah, your screen is visible. You can start the presentation now so that we can start the timer. Geeta, please hurry up, please. Next. Geeta Bharati, you will be given another chance. You will be surely given a chance, but we are. Please stop sharing. We will be giving chance to next participant. So I call upon Hari Prasad to present his screen. Hari Prasad, are you here?
Yes, sir. I am here, sir. Am I audible, sir?
Yeah, you are audible. Can we start the timer now?
No, sir. 1 second. I'll start sharing my screen, sir.
Okay.
Sir, whether the screen is visible now, sir?
Yeah, it is visible.
Yeah.
Can we start the
good
timer
evening, sir.
now?
Myself. Yes, sir. You can start the timer, sir. Myself as Hariprasad from National College. I'm going to present my presentation on the topic of requests. Here is the outline of what I am going to discuss today. First of all, before entering into quantum teleportation, we must have a intro about what quantum teleportation is. Actually, quantum teleportation is entirely based on hypothesis described by Einstein and his colleagues in 1935, named EPR paradox, which explains the concept of two particles. You can obtain two particles and separate them in space so that they would continue to share their properties as two halves of the whole. Thus, an action of one them can would instantly have an effect on other. This spooky action at a distance in Einstein would capable of violating the limit of speed of light. Uh, and we must have prerequisites of these following things, namely quantum entanglement, no cloning theorem, and qubits. Quantum entanglement is nothing but two particles linked together in certain way that no matter how far they are apart, they remains constant in their properties. Qubit is nothing but like bit is basic unit of information in classical computer. Qubit is basic unit of information in quantum computer. No cloning theorem explains that no two quantum states can be exactly cloned as it is when it is in unknown state. And when coming into quantum teleportation is technique to transfer information, quantum information from one transmitter to other of one location to another receiver of unknown pair, which is used to transport the arbitrary quantum state. The diagrammatic representation of quantum teleportation is shown in this slide. Next, we have some protocols which are to be followed while doing quantum teleportation. To transfer a quantum bit data, Alice and Bob, namely Alice is a transmitter and Bob is a receiver, Alice and Bob must use a third party named Telemon to send them an entangled qubit pair. Alice then performs some operations on her qubit, sends the result to Bob over a classical communication channel, and then Bob performs some operations on his end and receives the qubit data. Here is the step-by-step diagrammatic representation of qubit data, which Alice transmits to the Bob, and how Bob performs some work and receives at the receiver's end. And this is on October 4, 2022. It is a remarkable day on which these three scientists, namely Alan Aspect, John F. Glasser, Anton Jellinger, have awarded a Nobel Prize for his work in quantum teleportation. Their main aspect of work is their experiment with entangled photon, establishing the violation of Billy inequalities and pioneering quantum information science. They have a prize share of 1/3 for each. These are the individual work of Nobel laureates. John Glasser developed John Bell's ideas, including practical experiment. They supported quantum mechanics by clearly violating Bell inequality. This means that quantum mechanics cannot be replaced by a theory that uses hidden variables. Whereas Alan Aspect developed the setup using it in a way that closed an important loophole. He was able to switch the measurement settings after an entangled pair had left its source. And Anton Jellinger started to use entangled quantum states. Among other things, his research group has demonstrated a phenomena called quantum teleportation, which make it possible to move quantum state from one particle to another at a distance. Since teleportation is a myth for all the scientists, it was been also mentioned in some of the ancient texts of southern India. And quantum teleportation is days. The professors from various universities, along with the researchers from University of Queensland and National Institute of Standards and Technology, finding an important step towards implementing quantum internet, which will bring unprecedented capacity not accessibly with today's web. There are some challenges in accepting quantum teleportation. For optical quantum teleportation, there are many conditions that should be satisfied. The important condition is that a complete Bell measurement is to be achieved.
Prasad, the
yeah,
time's up. It's time to interact with the judges.
thank you. Yeah.
So when Einstein received Nobel Prize for which discovery? Can you hear
Sir,
me?
I'll see to it and wrote back. Sir. Yes, sir. I'm audible. Am I audible, sir?
When Einstein had received Nobel Prize for which contribution? Have any idea?
Sir, no, sir. I don't have idea on it, sir.
For which work he got Nobel Prize? He has done a lot of work, right? The quantum
Yes, sir.
theory, relativity. Then many
Sir,
more.
actually,
For which?
received a Nobel Prize in 1921, sir.
Okay. Are you sure?
Yeah, yes, sir. He received in 1921.
Okay. Good luck. Okay. Good luck.
Okay, thank you, sir.
Can you close the presentation?
Yeah, yes, sir. Yes, sir.
The next.
Can I call the next participant? Now I call upon V. Parivartana. Parivartana,
Parivartana, yes, sir.
can you able to share your screen now?
Yes, sir.
Carry on.
Sir, is my screen visible, sir?
It is visible. You can start your presentation.
Okay. Good evening, everyone. I'm going to present on the topic quantum teleportation, the incredible quest. Before going to know about quantum
Can you
teleportation,
make
we
it
must know.
presentation mode?
Presentation mode, big slide, showing 3 slides in one shot.
Is it okay, sir?
Show only one slide. You have 13 slides. 3 slides are visible now.
Excuse me, sir.
Ma Parivartana, can you hold your phone in landscape mode?
So now?
Yeah, it's visible, but can you turn on the presentation mode and hold the phone in landscape mode?
Just tilt your phone. Put your phone in the horizontal position, like before.
Phone vibrate பண்ண
Sir,
மாதிரி ஆட்டோல போட்டுருக்கேன்னு நினைக்கிறேன்.
Sir, will you please give me another chance? I'll recover in the last. I don't know how to do, sir.
I call upon the next participant in line. Yeah, Parivartana will be given chance once the list is clear.
Yes, sir.
Everyone in the list has finished. Now I call upon Shiva Priyadashini to present her work.
Yes, sir. 1 minute, sir. Sir, am I audible, sir?
Yes,
Hello?
ma. Just go ahead.
Yes, sir. Okay, sir. Sorry, start, sir. Hello?
Yeah, you can start your presentation.
Start, ma.
Yes, sir. Okay. Good evening, everyone. And my topic is I'm going to explain about the quantum teleportation, the incredible quest. So here, I'm going to cover up the topics of quantum teleportation, and then quantum entanglement and EPR theory, and then Bell's inequality, and then violation of Bell's inequality and Nobel Prize 2022. So, okay, what is quantum teleportation? So, quantum teleportation is the process of sharing an information from one object to the other without any physical link between them. This sharing can happen even at the largest distance. It is a billions of light years distance. This quantum teleportation happens when an object is disappear in one place and the object is appear in other places. So, this quantum teleportation was interpreted by Charles Bennett in 1993. Then, the quantum teleportation was the quantum teleportation is based on the phenomena called quantum entanglement. So, quantum entanglement is a design that explains how two subatomic particles can be linked with each other, even they are separated by billions of light years ago. So, if we change the state of one object, then the state of other objects will also be changed immediately even if they are at the largest distance. Okay, but Einstein did not accept this theory, this quantum entanglement, and he proposed a theory with other two scientists, Podolsky and Rosen. So the three scientists have proposed that quantum mechanics was incomplete, and Einstein called this quantum entanglement as spooky action at a distance. So here, they told that the quantum entanglement is violating the locality and realism of the real world. Here, what is locality? So in locality, nothing can travel greater than speed of light. So, but in quantum entanglement, the two particles can communicate, like photons, communicate with each other even at a speed greater than a speed of light. So Einstein told this is not possible. And then realism. So in realism, things have a definite value whether you measure them or not. But in quantum entanglement, the things in quantum entanglement, the two particles, if they communicate with each other, the particles can in both state. That is, we call it a superposition state. But Einstein didn't accept this, and he called the variable called hidden variable. So this hidden variable is connecting the two particles. So therefore, it does not violate the locality and realism. Then Bell comes and he formulated an equation. In the equation, he told that any particles which is measured is between the range of his equation. It works with the local realism, but it does not. If it violates his measurement, then it is a quantum particle and does not work with local realism. He called it as Bell's inequality. So Bell's inequality tells that local realism will not work with the quantum mechanics. So after that, the three scientists who have won the Nobel Prize 2022, they are John Clauser, Alan Expeid, and Anton Zeilinger. So here, John Clauser did an experiment called CHSH inequality. In that experiment, he experimented. He called two players, Alice and Bob, and having a referee Charlie. Here, Charlie has two signals plus or minus one. So he's giving the signals to Alice and Bob. They have two detectors. So in using this experiment, Clauser have concluded that this values would not exceed the according to Bell's inequality, the value of this equation would not exceed 2. But from his experiment, it exceeds 2, and thus he concluded that quantum entanglement is possible, and he violates the Bell's inequality. After that, aspects come, and he conducted an experiment with his colleagues, and he gives with his colleagues, and he closed the loophole of Clauser's experiment. He closed the deduction loophole, and then Zeilinger comes, the other scientist, Nobel scientist, and he gave the path of quantum teleportation with two entanglement particles. Thus, the three Nobel scientists violates the Bell's
Thank
inequality.
you, Shivapradeshni. Your time's up. Now you can interact with the judges.
Yes, sir.
So, Priyasni,
Yes, sir.
do you know this double slit experiment?
Yes, sir. Young's double slit experiment, sir.
Okay, suppose I am sending a beam of electrons through the double slit.
Yes, sir.
What will happen?
So, in Young's double slit experiment, actually, if send any particles, it would occupy the only two places. But in Young's double slit experiment, there is something happens which is due to the interference patterns, which is called constructive and destructive interference. So there are.
Okay, that's fine. Suppose I am sending only one electron
Yes, sir.
at a time.
If
So we get interference pattern. I'm sending only one electron.
No, sir.
No.
Because
Okay.
if we send two electrons only, we can. Yes.
Okay, fine. Thank you.
Thank you, sir.
Next candidate.
Sir, can we call the next participant?
Yes.
I call upon Murthy to share his PPT.
Good evening to all. Myself is Murthy.
Murthy, please share your screen first.
Hello, sir.
Share your screen.
Please 1 minute, sir. My screen visible, sir?
Yes.
Hello, sir.
Yes, go ahead.
Before seeing what is quantum teleportation, we should know about teleportation. How did teleportation form? When telecommunication and transportation were combined, it resulted in teleportation. Teleportation. When a matter or energy get transformed from one place to another place through the hypothetical mode, the information about the position, momentum, and intrinsic spin of electrons, protons, and neutrons of each atoms can be transferred from one place to another place. According to uncertainty principle, position and momentum of electron cannot be determined simultaneously with absolute accuracy. If we find position, the momentum will change. If we find momentum, the position will change. Teleportation is possible through quantum state. Quantum teleportation was invented by Sandu Popescu and Anton Zillinger. Quantum superposition and quantum entanglement play a vital role in quantum teleportation. Two electrons, A and B, in bottom spin and top spin respectively. They are simultaneously when the spin of electrons A and B measured. The superposition wave function of electrons is collapsed. As the result of collapsing, the spin of A and B becomes the same. Either it will become bottom spin or top spin. Quantum entanglement. When two particles, such a pair of photons and electrons, becomes entangled, they remain connected, each when separated by waves distance. Principle. When two particles A and B are in quantum superposition state, and during these states, particle A is allowed to interact with a photon. As a result, we are able to get information about the spin of particles A. After knowing the spin of particles A, the information about the behavior of particles A is transferred into particle B. Einstein-Podolsky-Rosen is a pair of qubits which are in a maximally entangled state. Application: quantum cryptography. Quantum crystallography allows the transmission of information with 100% security ensured by the law of physics. Potential applications for commerce and military purpose. Quantum key distribution, quantum coin flipping, position-based quantum cryptography. Quantum computing. Moore's law predicts the computer double its speed and memory performance, but size and weight of computer remains the same. Research in high energy physics, advertising and marketing, development of nitrogen fertilizer. Quantum teleportation, advantage and disadvantage. Advantage: transmission and high rates, secure data transmission, reduce cost of transportation. Disadvantage: quantum teleportation cannot occur faster than the speed of light. Thank you, sir. Hello, sir.
Yes. Yeah. Can you restate the Moore's law? You said Moore's law, right?
Yes, sir.
Can you restate again? Can you state again?
Moore's law, quantum computing. Moore's law predicts that computer double is speed and memory performance, but the size and weight of computer remains the same.
What do you mean computer doubles? The computer size or thickness becomes double?
Every 18 months, 18 monthsக்கு பிறகு அந்த ஸ்பீட் வந்து அதிகரிக்கும் சார் கம்ப்யூட்டருக்கு.
Okay, fine. Good luck.
Okay, sir.
Yeah, just you can put now. Stop presentation. Then we stop your presentation.
Murthy, you are requested to stop your presentation. I call upon next in line, Sharmila, to present their work.
Check my number, sir.
Good afternoon, sir. As my screen is visible, sir?
Yes, please go ahead.
Yes, sir. A very good morning, everyone. Good afternoon, everyone. So now we are for the presentation with the title of Quantum Teleportation, an Incredible Quest. So everything is theoretically impossible until it is done, goes the famous saying. So outline of our presentation is the introduction, beginning of teleportation, a barrier, which is Heisenberg uncertainty principle, a proven technology, which was a photon experiment, then some remarkable achievements, which is like Nobel Prizes. So latest researches, application in real world, advantages, and finally our conclusion. So introduction. So here what is teleportation means? It is a sum of telecommunication and the transportation. So recent research demonstrated quantum teleportation between atomic systems over a long distances. So the beginning. So initially, the quantum teleportation is a demonstration of what Albert Einstein famously called as spooky action at a distance, also known as quantum entanglement. So in entanglement, one of the basic concept of quantum physics, the property of one particle affect the properties of another. Yes, even when the particles are separated by a very large distance. So in 1993, so this was theoretically possibility which was proven by IBM. So the barrier, which is Heisenberg uncertainty principle. So such a quantum teleportation violates the Heisenberg uncertainty principle, according to which one cannot perform perfect scan of object to be teleported, because the more accurately an object scanned, the more it is disturbed by the scanning process. So therefore, it could be seen that a perfect copy cannot be made. So next, the EPR effect. So the existence of entanglement state was suggested in an experiment by three scientists in the year of 1935. It states when two particles come into contact with one another, they are become entangled. So these such also can be improved by California Institute of Technology in the year of 1998 with the two European groups. So next proven technology is a photon experiment. So here what is we are taking, the scientists are taking three photons, a photon A which consists to be teleported, and photon B is a transporting photon. Photon C is the entangled with P. So by this taking three photon, they are exacting the exact replica of photon A. Yes, however, photon A no longer exists as it before the information was sent to photon C. So the remarkable achievements is this. So from the earlier in the year of 1935, first Albert Einstein and that Proclepier effect has described about the hidden variables. Next, after him, in the year of 1964, John Bell devises the thought of which states entangled particles are too correlated with the hidden variables. And then after him, in the year of 1969, John Clausier has come to the real world data. So next, in the year of 1972, Clausier and his colleagues violate such Bell's inequality. Again, in the year of 1982, Alan Aspect from the France, he came with the violation of Bell's theorem, but a few loopholes are remained. Before that, in the year of 2017, the Australian physicist Anton Zeilinger and his colleagues has find out the hidden variables in what kind finally closes the door on Einstein. So finally, in the year of 2022, the Nobel Prize of Physics awarded to Clausier, Aspect, and Zeilinger for their exploration of quantum entanglement. So these are the one of the remarkable achievements. So here we have one doubt: such human teleportation is possible? Exactly no, because teleportation is possible now in a subatomic world of quantum mechanics. So application in real world is quantum cryptography. So potential application for commerce and military purposes, here we are using it. So it detects the eavesdropping and offers multiple methods for security. So quantum computation means, so it have artificial intelligence, better batteries, clean fertilization like cyber security, etc. Quantum computing can also help to make more accurate, simultaneous, and prediction for market activities. So here also we have telepresence system. So for the use of robot use of remote workers. So latest researches in the year of 2016, they are deduced about the long-range communication using exister fiber work, and also in the year of 2017, first commercial quantum communication have also been did. In 2019, IBM revealed a quantum computing system which is named as IBQ. So from in the year of 2021, so they realized the quantum teleportation onto mechanical motion. So also in the year of 2022, they are very closer with advanced data in teleportation. So here we were what having is in the year of 1935 the EPR paradox to 2021 until up to now such 127 qubits milestone have been achieved. So advantage or their transmission at a higher rates, secure data communication, the transportation much be easier. So reduced cost of transportation have been done.
Sharmila, thank you for your presentation. Now we can interact with the judges.
Yes, sir.
Okay, Sharmila.
Yes, sir.
Do you know what is de Broglie wavelength?
Yes, sir. De Broglie wavelength, he gives about the light, and it is one of the proven experiment for the duality of light, sir, which consists of both.
Listen. I'm asking the definition of de Broglie. Do you know? Or otherwise, okay, fine. No problem. Okay. Next candidate, no?
I call upon Geeta Bharati to share their
Yes, sir.
presentation.
Is my screen visible, sir?
Not yet.
Sir, is it visible now?
No. Do it again.
Yes, sir. Yes, sir. Is it visible now, sir?
No more. Yeah, it's coming now.
Yes, sir.
Go to presentation mode.
Yes, sir. Is it okay, sir?
Yeah, go ahead. Carry on.
Good evening, sir. And my presentation is on quantum teleportation. And what is quantum teleportation? It's nothing but it's a technique for transferring just a quantum information from a sender at one location to a receiver at some away distance. And this can travel at very high speed. but it never achieves the speed of light. And whether human teleportation is possible or not yet, only teleportation is made only on quantum state, and the sender will have to know only the particular quantum which they have to be transferred. And this picture represents a bell state which is generated with one qubit sent to location A and the other will be sent to location B, and the bell instrument of the bell state qubit and the qubit to be teleported is performed at location A, and using this classical channel the two bits will be sent from A to B, and they are potentially the time consuming step after step since information will be transferred in limit at the speed of light. And moreover, here researchers have also successfully used quantum teleportation to transmit information between clouds of gas atoms. And is quantum teleportation possible? Yes, it is possible. An entangled pair of particles will be shared between two separate locations, whatever may be the distance, and the encoded information will be teleported. And here, the implication of Heisenberg's uncertainty principle formulated that it is not a cloning theorem which prohibits making an exact copy of an unknown quantum state. And international team of 6 scientists, including Charles Lee Bennett, demonstrated that it is possible to transmit an unknown quantum state from one particular place to another at a faraway distance, and this process is known as quantum teleportation. And a very known cartoon we have seen at a Japanese manga story, Doraemon, will be considering as a very teleporting machine. And explanation of the phenomena, and this Bob Alice, and Alice is a sender and Bob is a receiver, and this explanation was put forth by David Ditch and Patrick Hayden. And the two bits that Alice have to send Bob that contain a local inaccessible information, and this ability of quantum information will flow through a classical channel. And this is the phenomena, and this picture represents the phenomena. And this is the sender and the receiver will be, the sender will be called as Alice and the receiver will be called as a Bob. And in the preparation process, Alice will prepare an EPR pair, the particle A and B, and the C will carry the information which is needed to be transferred. And here Alice performs a joint measurement, which is also known as Bell measurement, with particle A and particle C, and will get a result that will be the technique surveys the no cloning principle of quantum mechanics. After Bob get the outcome of the Bell measurement from Alice, the receiver, through traditional protocol, Bob can apply the unitary transformation to the result with a practice B to retrieve the state of the particle and the information contained in the particle C. Next, spooky action at a space. This is very known by Albert Einstein, famously called spooky action at a space, and it is also known as quantum entanglement. And the properties of one particle affect the properties of another, whatever the distance they are separated, whether the distance may be larger, independent of the distance. This quantum teleportation involves two distant entangled particles in which the state of the third particle instantly teleports the state of the two entangled particles. And this means transmitting information in a quantum computing. Typically, the millions of transistors are called bits, and the quantum computers will encode the information in quantum bits or qubits. And a byte has single binary value, which may be either 0 or 1 at the same time. Next, scientists have recently demonstrated that quantum teleportation by using electromagnetic photons that is created remotely entangled pair of qubits. Qubits made from the individual electrons are also transmitting information in semiconductors. Individual electrons or promising qubits, they can interact very easily with each other and creating an entangled pair of electron qubits, which the span is very span long distance, which you are required for quantum teleportation. But photons will naturally propagate over long distance, and electrons are usually confined to. Next, an experiment was done on across the Danube River, and this was conducted across the Danube River in Venia, a total of 600 meters. And here, the same Alice is a transmitter and Bob is a receiver. An 800-meter long optical fiber will be installed in the public sewer system underneath the river. Is clear from the picture. It is exposed to temperature change and several other environmental influences. Alice performed a joint Bell state measurement on photon B, and the input photon and the photon C, here entangled pair, is the photon C and B. And the photon B, the Bob receiver photon, will contain all the information of the input, and the B except for the phase rotation that depends on the state that he observed. And the experiment implemented an active feed format system, and that sends Alice measurement result via classical microwave channels with fast electro-optical modulator in order to exactly replicate what the input photon, that is the transmitter Alice, have just exactly replicate the informations. These are the experimental demonstrations of quantum teleportation done in different years. And
Bharati, thank you for presenting your work. Now you can interact with the judges.
So what is quantum tunneling? You talk about teleportation, right? It's a quantum teleportation. What is quantum tunneling? We could not hear you, Ma.
Quantum tunneling.
Do you know? Have any idea? Have you come across this word, quantum tunneling, or at least
Yes,
tunneling?
sir. It is quantum tunneling. Yes, sir. It is nothing but a wave function that is penetrating to a potential barrier.
Okay, how this is
A
different
quantum
from
mechanical process where a wave function will penetrate through a potential barrier.
Okay, so how this your teleportation is different from quantum tunneling? Is it same or different? And how is this different? Okay. Good luck. Think of it.
Okay, sir.
The next.
Now I call upon Parivartana to present us like this is the last presentation of this day.
Yes, sir.
3 Gita, 6 is Parivartana.
Sir, is my screen visible, sir?
Yes. Presentation mode. PPT board.
Is my screen visible, sir?
Yes.
Good afternoon, everyone. I am going to present on the topic quantum teleportation, the incredible quest. Before going to know about quantum teleportation, we must know what is teleportation. Teleportation is the hypothetical transfer of matter or energy from one point to another without transferring the physical state between them. In much simpler words, teleportation means to disappear and then reappear at different places. Imagine if we are in the place of a freezing cold, we probably think that we could teleport ourselves inside the place where it is much warmer. And now we are going to see about quantum teleportation. Quantum teleportation is a technique for transferring quantum information from a sender to one location to a receiver from some distance away. The principle of quantum entanglement, which means a phenomenon in which two distant particles in a quantum state remains in constant communication with one another. By taking advantages of this phenomenon, information can be transferred faster than the speed of light. The sender does not know the particular quantum teleportation. Classical information need to be sent from sender to receiver. And this is the diagram which shows what is quantum teleportation. Yearly article. Although quantum teleportation is a concept that has been theorized and reached for over 20 years, scientists have only recently started to gain an understanding of how it might be used in early life. Recently, the Nobel Prize for Physics 2022 was awarded for Alain Aspect, John F. Clauser, and Anton Zeilinger for experiment with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science. He is Anton Zeilinger. The second picture is him. Anton Zeilinger is an Austrian physicist who was awarded the 2022 Nobel Prize for Physics with his experiment with quantum entanglement. He shared the Nobel Prize with his colleagues, American physicist John F. Clauser and French physicist Alain Aspect. Zeilinger and his collaboration used quantum entanglement in 1997 to develop quantum teleportation, in which a state is transferred from one particle to another. This is done by entangling one particle in an entangled pair with a third particle. Then the third particle has the properties of another particle in the original entangled pair. Not only these three Nobel laureates shows what is quantum entanglement, there are many scientists who worked on what is quantum entanglement. We are going to see about Richard Joshua is an Australian mathematician who holds the Light Chapel Chair in Quantum Physics at the University of Cambridge. He is a fellow of King College, Cambridge, where his research investigates quantum information science. A pioneer of his field, he is the co-author of the Dishart-Josa algorithm and one of the co-inventor of quantum teleportation. And then Asher Peirce. Asher Peirce was the Israeli physicist. He is well known for his work relating quantum mechanics and information theory. He helped to develop the Peirce hierarchy criterion for quantum entanglement as well as the concept of quantum teleportation, and collaborated with others on quantum information and special relation.
William Wooters. William Bill Kidd Wooters is an American theoretical physicist and one of the founder of the field of quantum information theory. He is known for his contribution of the theory of quantum entanglement, including the quantum measures of it, entanglement assisted communication and the entanglement distillation, and also we are going to see some interesting facts that are recently updated in the field of quantum teleportation. In March 2021, Chinese researchers successfully completed a different kind of quantum teleportation experimenting using 5 quantum teleportation experiment using 5 quantum photons at location 870 miles apart. In February 2021, Chinese researchers shared their achievement completing a quantum teleportation experiment over a twin satellite link with a distance of 1203 miles, and this is the picture of the twin satellite. In May 2020, a scientist from the University of Science and Technology of China received a new milestone in the field of quantum teleportation, managing to teleport qubits of information over a distance of more than 50 kilometers for the first time. Here, the term qubit to teleport qubits of information. The term qubit, which are going to see in the upcoming slide, denotes the basic unit of quantum information originate in a conversation between Wooters and the scientist Wooter that we see in the previous slide. Conversation between Wooters and Schumacher in 1992. In March 2020,
Parivartana, now you can interact with the judges.
Sir, I'm not hearing your voice, sir.
The time is over, right? The time
Yes,
up?
sir. Yes, sir. Time's up, sir.
Okay. So what's the mass of the photon?
Sir?
What is the mass of the photon?
Yes.
Do electron have a mass, right?
Yes, sir.
Okay. Then what is the mass of the photon? Okay. You find out. Okay. Fine. Thank you.
Dear participants, the results will be announced at the award ceremony, which will take place tomorrow. We are rejoiced to have you all at the award ceremony. Sir, shall we wind up the meeting, sir?
Yes.
Yes, sir. We'd like to thank our dear participants and volunteers who have helped to conduct this smooth ceremony, our team members, and we are indebted to thank our judges who have took their time to take part in this event, and every other participant who will be coming tomorrow. Thank you.